Hello there, and welcome to Just About Earth, the place where we delve deep into the wonders of our planet, its past, and what the future holds. Today, we're embarking on an exciting journey to explore a question that might sound like the stuff of science fiction. What will Earth be like when the continents collide to form a new supercontinent? This isn't just an abstract concept. It's a geological process that's been unfolding for billions of years, and it's something that will inevitably reshape our world again in the distant future. As we ponder this, I want you to consider this. Have you ever thought about how Earth will look millions of years from now? What's your vision of a world that is so different from the one we live in now? It's a thought that invites both curiosity and a certain awe at the relentless, ever-changing nature of our planet. Before we dive deep into this topic, I'd love to know where you're listening from and what time it is in your part of the world right now. A little reflection on time, even as we talk about the long stretches of it that shape our planet, feels fitting. If this exploration fascinates you, please consider liking the video and subscribing. It's a small gesture that goes a long way in helping us share the wonders of Earth with others. Now, let's take a step back in time before we leap ahead into the far future. Today we're looking at Pangea Proxima, a time when the continents of our world will come together once again to form a supercontinent, similar to Pangaea, the one that existed hundreds of millions of years ago. It's an idea that blends geology, time and speculation, and it will leave you wondering about the forces at play beneath our feet. The story of Earth's continents is one of movement, a slow but powerful force that reshapes the very face of the planet. The Earth we know today is far different from the one that existed millions of years ago. Back then, what we now call continents were once joined together into a massive landmass. Imagine a time when all the land on Earth was connected in one vast supercontinent. This was Pangaea. But like all things in nature, Pangaea didn't last forever. It began to break apart, giving birth to the continents we recognize today. The geological processes behind this splitting of land masses are driven by the slow, unyielding movement of tectonic plates beneath our feet. These plates shift, collide, and pull apart over time, changing the layout of our planet. This constant motion, though it takes millions of years, means that the Earth's geography is never static. Now picture this, the distant future, hundreds of millions of years from now, when the continents will collide once again. Pangea Proxima, as some scientists have called it, will form just as its ancient predecessor once did. The process will begin long before we ever witness it, though it's difficult to imagine. But it is a certainty in the grand scheme of Earth's geological timeline. The continents will begin to converge as the tectonic plates continue their slow dance, the land masses drifting across the surface of the Earth, drawn together by the deep forces of the planet's internal machinery. This future supercontinent won't look exactly like the old Pangaea. It will have its own unique shape and geography, determined by the paths that the continents follow as they move. Just as the first Pangaea was shaped by the collision of continents that had been drifting apart for millions of years, Pangea Proxima will form when the land masses we know today begin to converge once more. The journey to this future Earth will take time, millions of years, and it will be a story told in geological layers, each one marking a moment in the long process of the Earth's transformation. When we look at the world today, it's easy to think of the continents as fixed, permanent features, but in reality, the land we stand on is in constant motion. The ocean floors are continually spreading, and the land masses are slowly moving toward one another. The Atlantic Ocean is widening, for instance, as the American continents drift away from Europe and Africa. At the same time, the Pacific Ocean is closing, pushing the Americas closer to Asia. Eventually, the movements of these tectonic plates will result in the formation of Pangea Proxima. This is the inevitable future for Earth. It will come, but not in our lifetimes, nor in the lifetimes of any of our descendants. It is a distant event in the grand timeline of our planet's existence, and yet it is a certainty. an inexorable force that drives the Earth's geological evolution. As we look ahead to this far-off future, we find ourselves in the unique position of being able to glimpse the future of Earth even though we will never witness it ourselves. The land we live on is always changing, and the supercontinent that will one day emerge will look nothing like the world we know today. The continents will shift, collide, and fuse together, creating a new world with new landscapes, new oceans, and perhaps new challenges for life on Earth. What we know as the Americas, Europe, and Africa will no longer be the familiar places we know now. Instead, they will be part of a new, unified landmass, reshaped by the forces of nature and the slow-moving currents of time. Though it's difficult to picture this distant future, it's important to remember that these transformations are always happening, even if they are happening far beyond our ability to perceive them. The Earth is constantly moving, constantly changing, and the cycle of continental drift will continue long after we're gone. This is not a process we can control, but it is a process we can study, a process we can understand. And while we can't stop the formation of Pangea Proxima, we can reflect on what this means for the world we live in today. The Earth's ability to reshape itself, to transform its very geography over millions of years, is a reminder of the dynamic nature of our planet and the forces that are always at work beneath the surface. The formation of a new supercontinent will be a monumental event in the history of Earth. It will mark the culmination of countless geological processes that have been at work for billions of years. And while we may never see it happen, it's something that will shape the future of our planet in ways that we can only begin to imagine. As the continents come together, they will create new mountains, new oceans, and new climates. The Earth's geography will be unrecognizable compared to what we know today, and yet, despite the changes, the Earth will continue its cycle of transformation, just as it always has. The story of our planet is a story of change, of evolution, of forces that shape the land and the life that calls it home. And Pangaea Proxima will be one of the most dramatic chapters in that ongoing story. Now that we've set the stage for what's to come, let's dive deeper into the forces that will drive the continents to collide once again. How will these movements take place? What will the world look like when the continents begin to merge? And how long will it take for Pangaea Proxima to form? These are the questions we'll explore next as we continue our journey through time, imagining the future of Earth when the continents collide once more. As we begin this journey through time, it's helpful to understand that the Earth we see today is not the same Earth that existed millions of years ago. Our planet has undergone dramatic changes, and it will continue to do so long after we're gone. When we think of the Earth's history, it's easy to imagine a steady, unchanging world, perhaps even a static one. But the reality is far from that. The Earth is in constant motion, constantly evolving, constantly reshaping itself. In fact, the continents themselves, the very land we walk on, are part of an ongoing dance of movement that has shaped, and will continue to shape, the world as we know it. To fully understand how Earth got to where it is today, and where it's headed in the future, we need to look back into the distant past, far beyond recorded history. The story of Earth's continents begins millions of years ago, long before humans or even dinosaurs roamed the land. Our story starts with the first supercontinent, one that existed over 600 million years ago. It was known as Rodinia, and it was a vast landmass that brought together many of the Earth's continents into a single, unified whole. But this was just the beginning. As with all things on Earth, Rodinia did not last forever. Over time, Rodinia began to break apart, and the fragments of land slowly drifted across the globe. This process, known as continental drift, set the stage for what would come next. Eventually another supercontinent emerged from the chaos, the supercontinent we know as Pangaea. Pangaea was a landmass of unprecedented size, covering almost a third of the Earth's surface. It existed around 335 million years ago, and it was surrounded by a vast ocean known as Panthalassa. Unlike Rodinia, Pangaea didn't break apart all at once. Instead, it began a gradual process of rifting and splitting, a process that would ultimately give rise to the continents we recognise today. The story of Pangaea's breakup is a tale of immense geological power. It's the story of tectonic plates, the massive pieces of the Earth's crust that float on the mantle beneath them, slowly shifting and pulling apart, creating the oceans and seas that separate the continents. These tectonic movements are driven by the immense heat generated within the Earth's core. The heat causes the mantle beneath the Earth's crust to flow in currents, a process known as mantle convection. As the mantle moves, it drags the tectonic plates along with it, causing them to move and interact in complex ways. At first glance, the movement of these plates seems slow, almost imperceptible. But over millions of years, these tiny shifts have added up, resulting in the vast oceans we see today, as well as the sprawling continents that stretch across the Earth's surface. The forces behind continental drift are not just powerful, they are relentless. The Earth's continents are not static. They are always on the move, slowly but surely. And the story of Pangaea's breakup was just one chapter in a much larger, ongoing story of geological transformation. As Pangaea began to break apart, the land was divided into two major land masses, Laurasia in the north and Gondwana in the south. These two supercontinents eventually split further, giving rise to the continents we know today: North America, South America, Europe, Asia, Africa, Antarctica, and Australia. But just because the land was divided doesn't mean the process of continental drift stopped. The continents continued to move, often at a rate of just a few centimetres per year, but over millions of years this movement has reshaped the entire planet. The movement of the continents didn't just alter the geography of Earth, it also had a profound effect on the planet's climate. When Pangaea existed, the majority of the land was concentrated in the southern hemisphere. This meant that the northern hemisphere was mostly ocean, and the climate was much warmer than it is today. As the continents broke apart and spread out across the globe, new ocean currents were created, and the Earth's climate began to shift. The oceans, which once covered most of the planet's surface, became divided into smaller, distinct bodies of water. The shifting of the continents also affected the Earth's atmosphere, altering wind patterns and influencing the weather. These changes didn't just affect the climate, they also had a significant impact on life on Earth. As the continents drifted apart, they created isolated environments that allowed new species to evolve. This isolation led to the development of unique ecosystems, with different plants and animals evolving in different regions. Some species thrived in the new environments, while others went extinct. The history of life on Earth is inextricably linked to the movement of the continents. The rise and fall of species, the diversification of life, and the extinction of others all have their roots in the shifting of the continents. Fast forward to the present day, and we see a world that has been shaped by millions of years of geological activity. The continents, though seemingly fixed in place, are still moving. The Atlantic Ocean continues to widen, the Pacific Ocean is closing, and new mountains are rising while old ones erode away. The forces of continental drift have not stopped. They are still at work, constantly shaping the Earth in ways that are too slow for us to perceive in our lifetimes, but which have a profound impact on the long-term evolution of the planet. As we think about the future of Earth, we can look to the past for clues. Just as Pangaea once broke apart to form the continents we know today, the continents will one day collide again, forming a new supercontinent. This process will take millions of years, but it is an inevitable part of the Earth's ongoing transformation. The formation of a new supercontinent will reshape the Earth's geography, climate, and ecosystems in ways we can only begin to imagine. And just as life on Earth has adapted to the changing continents in the past, it will adapt to the new supercontinent in the future. But what will this new supercontinent look like? Will it resemble Pangaea, or will it be something entirely different? The answers to these questions lie in the movement of the tectonic plates that continue to drift across the Earth's surface. Over time, these plates will converge once again, creating a new landmass that will bring the continents together in ways that are impossible to predict. The process will be slow, but the results will be dramatic. And as the Earth continues to evolve, it will continue to surprise us with the power of its geological forces. In the next part of our journey, we will explore how the tectonic forces that drive continental drift will eventually lead to the formation of Pangea Proxima. What will this new supercontinent look like? How will the continents collide, and what will happen to the oceans and climate as they come together? The future of Earth is a story of slow but unstoppable change, and it's a story that is still unfolding, one tectonic shift at a time. As we continue on our journey through time and space, let's take a closer look at the fundamental forces that drive the constant reshaping of Earth. Forces that, though invisible and gradual, have a profound impact on the world we live in today. These forces are the movement of tectonic plates, a slow and steady dance that has shaped the Earth's continents for billions of years. To understand how Earth will look when the continents collide once again, it's essential to first understand the dynamics of tectonic activity and the crucial role it plays in the formation and destruction of supercontinents. The Earth's outer shell, the lithosphere, is broken into several large and small pieces known as tectonic plates. These plates float atop the Earth's semi-fluid mantle, the layer beneath the crust. The mantle is composed of hot, molten rock, and the plates themselves are like massive puzzle pieces, moving ever so slowly across the surface of the planet. This movement is driven by heat from the Earth's core, which causes the mantle to convect or circulate. As the molten rock rises near the surface, it cools, moves horizontally, and then sinks again, continuing the cycle. This continuous movement creates a kind of conveyor belt beneath the Earth's surface, slowly shifting the continents around over millions of years. The movement of these tectonic plates is not immediate. It happens so gradually that it's almost imperceptible in a human lifetime. The average rate at which plates move is around 2.5 centimeters per year, roughly the speed at which human fingernails grow. But over millions of years, this seemingly slow pace adds up to dramatic changes. Imagine the Earth's crust is a giant jigsaw puzzle, and as the pieces shift, they rearrange the continents, form mountains, create oceans, and occasionally push entire land masses into one another. It's this process that has driven the breakup of supercontinents like Redefining and Pangea, and it will continue to shape the Earth long into the future. This process of movement begins at what we call plate boundaries, the edges where two tectonic plates meet. The interaction between these plates at the boundaries is the key to understanding how continents drift. There are three main types of plate boundaries: divergent, convergent, and transform. Each type of boundary behaves in a unique way, driving different geological processes and forming various landforms on Earth's surface. At divergent boundaries, tectonic plates are moving apart from one another. As the plates separate, magma from the mantle rises to fill the gap, solidifying to form new crust. This is most commonly seen at mid-ocean ridges, where the ocean floor is slowly being pulled apart. For example, the Mid-Atlantic Ridge, located under the Atlantic Ocean, is a divergent boundary that is slowly widening, causing the American and Eurasian plates to move apart. Over millions of years, this process has created the Atlantic Ocean and is contributing to the widening of it even today. Convergent boundaries, on the other hand, occur when two tectonic plates collide. This is where much of the dramatic action happens. When plates collide, the crust can be pushed upward to form mountains or forced down into the mantle in a process known as subduction. The Himalayas, for instance, are the result of the collision between the Indian and Eurasian plates. As the two plates collide, they push upward, creating the towering peaks that continue to rise. Similarly, when oceanic plates collide with continental plates, the denser oceanic plates are forced beneath the lighter continental plates, creating deep ocean trenches and triggering volcanic activity. The Mariana Trench, the deepest part of the world's oceans, was formed by such a subduction zone. Lastly, transform boundaries occur when two plates slide past one another horizontally. These boundaries are typically found along faults, such as the San Andreas Fault in California. At these locations, earthquakes are common as the plates grind against each other. While the movement here isn't as visually dramatic as that at divergent or convergent boundaries, it can still cause significant disruption on the Earth's surface, with earthquakes shaping the land and creating new geological features over time. The movement of tectonic plates is driven by a variety of forces. The most significant of these is mantle convection, but gravity also plays a role. As the oceanic crust forms at divergent boundaries, it becomes denser and eventually sinks back into the mantle at subduction zones, a process known as slab pull. Meanwhile, at divergent boundaries, new crust is being formed and pushed outward by the force of mantle convection. These processes create a system of forces that constantly shift and recycle the Earth's crust, driving the slow and steady movement of tectonic plates. While the movement of these plates happens at a glacial pace, the impact on the Earth's surface is far from subtle. As plates move, they shape the landscape, creating new mountains, valleys, oceans, and continents. One of the most notable effects of tectonic movement is the formation and breakup of supercontinents. The idea of Pangaea, the supercontinent that existed around 335 million years ago, is a prime example of how tectonic forces can assemble landmasses into a singular, unified whole. Pangaea was once all-encompassing, with almost every continent on Earth being part of this giant landmass. But the story of Pangaea is one of both creation and destruction. As the tectonic plates slowly shifted, Pangaea began to fracture. The breakup of Pangaea, which began around 175 million years ago, eventually created the continents we know today. Over time, these continents drifted apart, carried by the slow motion of the tectonic plates beneath them. The result was the separation of the land masses into their current positions. North America, South America, Europe, Africa, Asia, and the rest. Yet, even though the continents are separated today, they continue to drift, albeit very slowly. Every year, the Atlantic Ocean grows wider, the Pacific Ocean shrinks, and new rift zones are created across the Earth's surface. But what does this mean for the future? If the tectonic plates are always in motion, what happens next? Will the continents continue to drift apart, or will they eventually come together again? The answer lies in the long-term effects of this tectonic movement. Just as Pangaea once broke apart to create the world we know today, the tectonic plates will eventually come together again to form a new supercontinent. This process is already underway, though it will take millions of years to reach its culmination. This new supercontinent is often referred to as Pangea Proxima, a future version of Earth where the continents will collide once more. The slow, inevitable movement of tectonic plates is a reminder of the dynamic nature of our planet. Earth is never static. The tectonic plates beneath our feet are constantly shifting, pulling apart and colliding, reshaping the landscape in ways that take place over timescales so long that they seem imperceptible in our daily lives. And yet, when we look at the big picture, we can see how this slow and steady dance is shaping the Earth's future. Pangaea Proxima will one day be born, and when it does, it will bring with it a new era of Earth's history, one that will forever alter the planet's geography and climate. As we move forward in this exploration, we will delve deeper into the forces that will guide the formation of Pangea Proxima, considering the long-term effects of tectonic movements and how they will continue to shape the world in ways we can only begin to imagine. The Earth's surface is a living, breathing thing, and as the tectonic plates continue their slow dance, they will write the next chapter in the story of our planet. As we continue to explore the forces that have shaped and will continue to shape the Earth's surface, it's time to dive deeper into the fundamental drivers behind the colossal collisions of tectonic plates. The movement of these plates is not random. It is orchestrated by powerful, often invisible forces that lie deep within the Earth's interior. Understanding these forces, how they arise, how they interact, and how they shape the continents is key to understanding why and how the Earth will one day see the return of a supercontinent like Pangea Proxima. The first force at play is the most obvious: the heat from the Earth's core. The interior of the Earth is incredibly hot, much hotter than the surface, and it plays a vital role in the movement of the tectonic plates. The heat causes the mantle, the layer of the Earth just below the crust, to behave like a fluid, even though it is made up of solid rock. The high temperatures cause the mantle material to become less dense, and as it rises toward the Earth's surface it cools and becomes denser again, eventually sinking back down into the mantle. This process is known as mantle convection, and it is one of the most fundamental forces driving the movement of tectonic plates. Mantle convection is similar to the way water circulates in a pot when heated. When the bottom of the pot heats up, the water near the bottom becomes less dense and rises to the surface, while the cooler water on top sinks. In the Earth's mantle, the same principle applies, but on a much larger scale. As the mantle material rises toward the Earth's surface, it carries the tectonic plates along with it. This process is continuous and happens over millions of years, slowly but surely driving the movement of the plates. But mantle convection is not the only force at play. Gravity also plays a significant role in the movement of tectonic plates. Gravity's effect on the plates is most noticeable at subduction zones, which are regions where one tectonic plate is forced beneath another. When two plates collide, the denser plate is pushed downward into the mantle, where it melts and is recycled. The process of subduction is one of the primary ways that tectonic plates are moved and reshaped. The force of gravity pulls the denser plate down, dragging the rest of the plate along with it. This is what's known as slab pull, and it is a key mechanism in the movement of tectonic plates. In addition to slab pull, there is also the force of ridge push. Ridge push occurs at divergent boundaries, where tectonic plates are moving apart. At these boundaries, new crust is being created as magma rises from the mantle and solidifies, forming new oceanic crust. As the new crust is formed, it pushes the older crust away from the ridge, causing the plates to move apart. This process is most noticeable at mid-ocean ridges, such as the Mid-Atlantic Ridge, where the ocean floor is being pulled apart as new crust is created. The rising magma essentially acts like a conveyor belt, pushing the plates away from each other and driving the process of continental drift. While mantle convection, slab pull and ridge push are the primary forces driving the movement of tectonic plates, they are not the only factors influencing the behaviour of the Earth's crust. The composition and structure of the crust itself also play a role in determining how the plates move and interact. The Earth's crust is made up of two main types of rock: oceanic crust and continental crust. Oceanic crust is denser and thinner than continental crust, which means that when the two collide, the oceanic crust is usually subducted beneath the continental crust. This difference in density is one of the reasons why oceanic plates tend to sink into the mantle during subduction, while continental plates remain above the surface. The interaction between these different types of crust is another key factor in the formation of mountain ranges, volcanic activity, and the general shape of the Earth's surface. When two continental plates collide, neither plate is subducted into the mantle. Instead, the plates push against each other, causing the crust to buckle and fold, forming towering mountain ranges. The Himalayas, for example, are the result of the collision between the Indian and Eurasian plates. As the plates collided, the crust was compressed and forced upward, creating one of the highest mountain ranges in the world. This process is known as continental collision, and it continues to shape the Earth's surface as tectonic plates continue to move and collide. One of the most striking examples of the forces behind the collisions of tectonic plates is the Pacific Ring of Fire. The Ring of Fire is a horseshoe-shaped area around the Pacific Ocean that is characterized by high levels of seismic activity. including earthquakes and volcanic eruptions. This region is the result of the intense tectonic activity at the convergent and divergent boundaries of the Pacific Plate. The constant movement of the Pacific Plate, along with the subduction of oceanic crust beneath it, creates the conditions for the formation of volcanoes and deep ocean trenches. The Ring of Fire is a prime example of how tectonic plate collisions can lead to the creation of some of the most dramatic and destructive geological features on Earth. These forces, the heat from the Earth's core, mantle convection, slab pull, ridge push, and the varying densities of the crust, are responsible for driving the movement of tectonic plates. Together, they create a complex and interconnected system of forces that constantly shape and reshape the Earth's surface. The collisions of these plates lead to the formation of mountain ranges, the opening of new oceans, and the destruction of old land masses. The movement of tectonic plates is an ongoing, dynamic process that has been shaping Earth for billions of years and will continue to do so for billions more. But what does all of this mean for the future of the Earth? How will these forces play out in the formation of Pangea Proxima, the next supercontinent? The slow dance of tectonic plates, driven by these powerful forces, will eventually bring the continents together once more. As the plates move and collide, they will form new land masses, create new mountain ranges, and shape the climate and ecosystems of the future. This is the grand geological cycle, the birth, death, and rebirth of continents that will continue to play out over the course of Earth's long history. As we look ahead to the future, it's important to remember that the forces behind the collisions of tectonic plates are not just powerful, they are inevitable. The Earth's crust is constantly moving, reshaping itself, and preparing the stage for the next chapter in the story of our planet. In the distant future, when the continents collide once again to form Pangea Proxima, the forces that have been at work for millions of years will create a new Earth, one that will be both familiar and foreign, shaped by the same tectonic forces that have shaped our world today. So, as we continue to explore the future of Earth and the coming of Pangea Proxima, let's keep these forces in mind. The slow but relentless movement of the Earth's tectonic plates is a reminder that change is constant, and that the world we know today is merely one chapter in the long, ever-evolving story of our planet. As the plates continue their slow dance, they will continue to shape the Earth in ways that we can only begin to imagine, and in doing so, they will set the stage for the next great transformation of our planet. The birth of Pangea Proxima is a vision that lies far beyond our current lifetimes. It is a slow process, spanning millions of years, that will reshape the entire face of Earth. But as we look forward to this eventuality, we can begin to piece together how this new supercontinent might form using the forces that we have already discussed. The tectonic movements that are at work right now, the shifting of plates, the rifting of oceans, the folding and faulting of the Earth's crust are laying the groundwork for a new Pangaea, one that will emerge long after we have faded from the Earth's history. To understand how Pangaea Proxima will come into being, it's necessary to first look at how its predecessor, Pangaea, was born. Around 335 million years ago, Pangaea was formed as the continents, driven by the same tectonic forces we see today, collided and fused together. This process, known as continental collision, is the core mechanism behind the formation of supercontinents. As the continents came together, they reshaped the planet's geography, creating vast new mountain ranges, altering ocean currents, and shifting climate patterns in ways that profoundly impacted life on Earth. This same process is now underway once again, as the plates that currently make up the continents are slowly converging to form a new landmass. But the formation of Pangea Proxima won't look exactly like the old Pangaea. The dynamics of Earth's tectonic forces are constantly changing, and the paths that the continents are following are not identical to those of their predecessors. The Pacific Ocean, for example, is closing rather than expanding, while the Atlantic Ocean is growing wider. These differences in the tectonic processes will mean that the next supercontinent will take on a different shape, one that is influenced by the specific movements of the plates at the time of its formation. It's possible that some of the same land masses, Africa, the Americas and Asia, will collide once again, but the arrangement will be unique, determined by the intricate dance of the Earth's crust. One key factor in the formation of Pangea Proxima is the closing of the oceans that currently separate the continents. The Pacific Ocean, for instance, is shrinking due to the subduction of oceanic crust beneath the surrounding continental plates. As the Pacific shrinks, the continents around it will begin to collide. One of the most dramatic effects of this collision will be the formation of a vast mountain range, as the oceanic plates are forced down into the mantle and the continental plates are pushed up. This process will create new landforms shaping the geography of the future supercontinent. The Andes, the Himalayas and the Alps. These are all examples of mountain ranges formed by continental collision, and new ranges will rise as Pangea Proxima is born. At the same time, the Atlantic Ocean, which has been widening over millions of years, will eventually begin to close. As the continents on either side of the Atlantic, such as North and South America on one side, and Europe and Africa on the other, begin to converge, they will create a massive landmass. The Mediterranean Sea, which separates Europe from Africa, will likely close up as well, further connecting the two continents. As these landmasses collide, the result will be a supercontinent that is vastly different from the one that existed before, both in shape and in the way it affects the global climate. The formation of Pangea Proxima will not be a sudden event, but rather a slow, gradual process that takes millions of years. The movement of tectonic plates is imperceptible to us on a day-to-day basis, but it is happening all the time. The plates are moving at a rate of a few centimeters per year, and over millions of years this movement adds up. The collision of the continents, the closure of the oceans, and the birth of new mountain ranges and landforms will be a gradual unfolding of forces that are beyond human comprehension. We can't predict the exact shape of the new supercontinent, but we can make educated guesses based on the current movement of the plates and the patterns we see in the Earth's history. One thing we do know is that the geography of Pangea Proxima will have profound effects on the climate. The arrangement of the continents will influence ocean currents, wind patterns, and the distribution of heat around the planet. As the continents come together, they will block and redirect the flow of air and water, creating new climate zones. The new supercontinent will likely have a large central landmass that is far from the moderating influence of the oceans, leading to more extreme temperatures. The areas near the equator will be much warmer, while the regions closer to the poles will experience more extreme cold. The climate will be shaped by the vast landmass that will stretch from pole to pole, with large deserts and mountain ranges forming in the heart of the supercontinent. This shift in climate will have profound consequences for life on Earth. The changing geography and climate will force species to adapt, migrate, or face extinction. As the continents collide, ecosystems will be disrupted and new ones will emerge. The process of evolution will be accelerated as species are forced to adapt to new environments, new food sources and new climates. Just as Pangea's breakup led to the diversification of life, the formation of Pangea Proxima will likely lead to new species evolving to thrive in the new world. But before we get too far ahead of ourselves, it's important to remember that this process will take millions of years. Pangaea Proxima is not something that will occur in our lifetimes, or even in the lifetimes of our descendants. It is a long-term geological event that will unfold over an unimaginable span of time. The forces that are driving the movement of the continents today are slow, but they are unstoppable. The collision of the continents is inevitable, and the formation of the next supercontinent is simply a matter of time. In the meantime, the movement of tectonic plates continues to shape our world. New earthquakes and volcanic eruptions are constantly occurring, and the landscapes of our planet are continually changing. But the most dramatic changes are still to come. As the plates converge and the oceans close, a new world will begin to take shape. one that will be both familiar and alien to us. The birth of Pangea Proxima will be a monumental event in the history of Earth, and though we won't be here to witness it, it's something we can look forward to as the ultimate example of the Earth's dynamic, ever-changing nature. The birth of Pangea Proxima will not only reshape the physical geography of Earth, but it will also influence the course of life on the planet. The changing climate, the closing oceans, and the rising mountains will create new challenges and opportunities for life. The story of this new supercontinent is a story that will be written over millions of years, but it will be shaped by the same forces that have shaped Earth since its formation. And as the continents collide, we will once again witness the incredible power of nature at work. As we move forward in our exploration of the distant future, let's now turn our attention to the geography that will emerge with the formation of Pangea Proxima. What will the world look like when the continents collide once again, forming a new supercontinent? The answer lies in the current movement of the tectonic plates, as well as the long-term forces that will shape the Earth's surface over millions of years. While we cannot know with certainty the exact geography of Pangea Proxima, we can make some educated predictions based on the processes currently at work beneath the Earth's crust. At the heart of this new supercontinent will be a vast, unified landmass. The current continents, Africa, the Americas, Europe, Asia, and others, are gradually moving toward each other. The Atlantic Ocean, which has been widening for millions of years, will begin to close as the tectonic plates that form the oceanic crust are pushed back into the mantle. As the ocean shrinks, the continents on either side will collide, forming one giant landmass, much like the ancient Pangaea. But unlike the first supercontinent, which existed about 335 million years ago, the geography of Pangea Proxima will be shaped by the specific movements of today's plates, the current positions of the continents, and the new interactions between them. One of the most notable features of Pangea Proxima will be its central landmass, which will stretch across much of the Earth's surface. This central supercontinent will likely be located near the equator, with vast deserts and mountainous regions at its heart. Because of its size and position, this new landmass will experience extreme temperature variations, from scorching heat in the equatorial regions to frigid cold at the poles. Unlike the current continents, which are separated by vast oceans, Pangea Proxima will have no oceans between the landmasses. Instead, vast inland seas will form within the supercontinent, creating new bodies of water and reshaping the climate. The collision of the continents will also result in the formation of massive mountain ranges, much like the Himalayas, which were formed by the collision of the Indian and Eurasian plates. As the continents converge, the crust will be compressed, and the land will be pushed upward. The resulting mountain ranges will likely stretch across the entire width of the supercontinent, creating towering peaks and deep valleys. These new mountains will have a profound effect on the climate, as they will block air and ocean currents, creating different weather patterns on either side of the range. This central region of Pangea Proxima will likely be arid and inhospitable, while the coastal regions may have more temperate climates, depending on the surrounding oceans and seas. The closure of the Atlantic Ocean will also have a major impact on the geography of the future supercontinent. As the continents of the Americas, Europe, and Africa collide, new landforms will emerge. The Mediterranean Sea, which currently separates Europe from Africa, will likely close as the two continents converge. This will create a land bridge between the two, connecting Europe and Africa to form a single mass of land. The closure of the Mediterranean will also affect the climate of the surrounding regions. Without the moderating influence of the sea, the climate in Europe and North Africa will likely become much more extreme, with hotter summers and colder winters. Meanwhile, the Pacific Ocean will continue to shrink as the tectonic plates that form the oceanic crust are subducted beneath the surrounding continents. This process will eventually bring the Americas closer to Asia, creating a new landmass that will connect the two. The closing of the Pacific will also lead to the formation of new mountain ranges along the western coasts of the Americas and Asia. These mountains, much like the Andes, will rise as the plates collide, and they will shape the landscape of the new supercontinent. In addition to these major geological changes, Pangaea Proxima will also be affected by the redistribution of Earth's oceans. As the continents converge, the existing oceans will be reconfigured and new seas will form within the supercontinent. The closure of the Atlantic will lead to the creation of a new central ocean, which will stretch across the middle of the landmass. This ocean will create a dramatic division between the northern and southern regions of Pangaea Proxima, with the northern hemisphere likely being dominated by vast, arid deserts, and the southern hemisphere experiencing more temperate climates. The new geography will also influence the circulation of ocean currents, which will, in turn, affect the global climate. While the land masses will converge to form a single supercontinent, the exact shape and structure of Pangaea Proxima will be influenced by the current positions of the continents and the ongoing movement of tectonic plates. The new supercontinent may not resemble Pangaea in every way. For example, the positioning of Antarctica and Australia in relation to the rest of the continents may differ significantly from the ancient supercontinent. As the plates move, they will create new boundaries, rift zones, and ocean basins. These geological features will further shape the geography of the supercontinent, creating a landscape that is both familiar and foreign to us. One of the most striking aspects of Pangaea Proxima will be the vast interior regions of the supercontinent. Because of the lack of surrounding oceans, the central regions of Pangaea Proxima will experience extreme temperature variations. The vast land masses will be far from the moderating influence of the oceans, meaning that the interior will likely be very hot in the summer and extremely cold in the winter. This will create a variety of climate zones within the supercontinent, from dry desert-like conditions in the centre to more temperate climates along the coasts. These dramatic shifts in climate will have profound effects on the ecosystems that develop within Pangaea Proxima. The geography of Pangaea Proxima will also have an impact on the flow of ocean currents and the distribution of heat around the planet. The shape of the new supercontinent will alter the patterns of ocean circulation, which are driven by the position of the continents and the distribution of heat across the globe. As the supercontinent forms, it will disrupt the current flow of the oceans, creating new patterns of circulation that will affect the climate of both the supercontinent and the rest of the world. These changes in ocean currents will likely influence global weather patterns, leading to shifts in the location of deserts, rainforests, and temperate zones. The impact of Pangaea Proxima's geography on the climate will also be felt in terms of the distribution of rainfall. With the central regions of the supercontinent being far from the ocean, they will likely experience much less rainfall than the coastal regions. This will lead to the development of vast deserts in the heart of the supercontinent, similar to the deserts of Central Asia today. Meanwhile, the coasts will have more moderate climates, with the ocean currents providing a source of moisture that will create more temperate environments. As we think about the geography of the future supercontinent, it's important to remember that it will not just be a collection of land masses, but a dynamic and ever-changing landscape. The forces of tectonic activity will continue to reshape Pangaea Proxima long after it has formed, creating new mountain ranges, oceans, and climates. The geography of the supercontinent will be a living, breathing thing, influenced by the ongoing movement of the Earth's tectonic plates. Though Pangaea Proxima will emerge in the distant future, the forces that will shape its geography are already at work today. The movement of the tectonic plates is a slow, gradual process, but it is inevitable. As the continents collide and fuse together, the face of the Earth will change in ways that we can only begin to imagine, and while we may not be here to see it, the geography of Pangaea Proxima will be the culmination of the Earth's ongoing transformation, a testament to the slow, powerful forces that shape our planet. As the tectonic plates continue their slow but steady drift across the surface of the Earth, they not only shape the land masses but also redefine the oceans that surround them. The future supercontinent, Pangaea Proxima, will be an entirely different world, and the oceans that exist today will undergo dramatic changes as the continents collide and rearrange. The changing geography will influence the shape, size, and distribution of the oceans, leading to new patterns of circulation, temperature, and ecosystems. The oceanic shifts will not just affect the land, they will have profound consequences for the atmosphere, the climate, and life on Earth. To understand the future oceans of Pangea Proxima, we need to explore the forces at play today and how they will continue to evolve over millions of years. Currently, the Earth's oceans cover more than 70% of the surface, with 5 major oceans: the Atlantic, Pacific, Indian, Southern, and Arctic. These oceans are not static. They are constantly in motion, influenced by the movement of tectonic plates, the currents of the atmosphere, and the rotation of the Earth itself. The ocean floors are slowly spreading apart at divergent boundaries, and at convergent boundaries, oceanic plates are subducted beneath continental plates. This process constantly reshapes the ocean basins and affects the distribution of water across the planet. However, when the continents begin to collide and form Pangea Proxima, the oceans that we know today will be fundamentally altered. The first significant change will be the closure of the Atlantic Ocean. Over millions of years, the tectonic plates separating the Americas from Europe and Africa will gradually push towards one another, closing the gap between them. This will lead to the collision of the continents and the eventual formation of a massive landmass in the centre of the Earth. As the Atlantic Ocean shrinks, the remaining body of water between the converging continents will become smaller and more confined, eventually forming a narrow inland sea running through the middle of Pangea Proxima. The shrinking of the Atlantic will not be the only change to the Earth's oceans. The Pacific Ocean will also undergo a significant transformation. Currently, the Pacific Ocean is the largest and deepest of the world's oceans, separating the Americas from Asia and Australia. As the tectonic plates of the Pacific are subducted beneath the surrounding continental plates, the ocean basin will shrink. The Pacific's narrowing will bring the Americas and Asia closer together, eventually merging these two landmasses into one unified supercontinent. The process of subduction will cause volcanic activity along the edges of the plates, which will further reshape the ocean floor and contribute to the formation of new mountains, volcanoes, and geological features. As the Pacific closes, a new, vast oceanic basin will be created, likely stretching along the western edge of Pangea Proxima, with the closing plates forming mountain ranges on either side. The closing of the Atlantic and Pacific Oceans will not only reshape the Earth's physical geography, but will also have a profound impact on the global climate. Oceans play a crucial role in regulating the Earth's temperature, storing and distributing heat from the equator to the poles. The movement of water through currents and the heat exchange between the ocean and atmosphere help create the conditions for life on Earth. As the oceans change in Pangea Proxima, the ocean currents will shift, altering the way heat is distributed across the planet. In the current Earth, the Atlantic and Pacific Oceans are key players in the global circulation of water. The Gulf Stream, for example, carries warm water from the tropics to the North Atlantic, warming the climate of northwestern Europe. The closing of the Atlantic will disrupt this flow of water, leading to significant shifts in the climate of regions that are currently affected by these ocean currents. Europe, for example, could experience much colder temperatures as the flow of warm water from the Gulf Stream is cut off. Similarly, the closing of the Pacific will change the patterns of ocean circulation that currently affect the western coasts of the Americas and Asia. This will lead to new weather patterns, with some regions becoming much wetter or drier than they are today. Another significant change will be the formation of new seas and inland bodies of water within the supercontinent. As the continents come together, vast land masses will separate the oceans from one another. In the heart of Pangea Proxima, large inland seas will form, creating a series of isolated bodies of water that will serve as unique ecosystems. These seas will be unlike the open oceans we know today. They will be confined by the surrounding land, and the lack of oceanic circulation will lead to more stagnant, less oxygenated waters. The climate within these inland seas will likely be harsh, with temperature extremes and limited biodiversity, as the waters will be cut off from the moderating effects of the global ocean currents. One of the most dramatic impacts of the changing oceans will be the shifting of coastlines. As the continents move, The coastlines of the future supercontinent will be vastly different from those of today. The shallow seas that surround the continents will be pushed inland, and the current coastlines, like those along the eastern United States or the western coast of Africa, will be no more. Instead, new coastlines will emerge, shaped by the collision of the continents and the rising of new mountains and landmasses. These new coastlines will be exposed to different patterns of ocean currents and tides, which will, in turn, shape the climate and ecosystems of the coastal regions. The formation of Pangea Proxima will also have an impact on the deep ocean basins. As the oceanic plates are subducted into the mantle at convergent boundaries, the deep ocean trenches will disappear and new trenches will form at the sites of the tectonic collisions. These deep ocean trenches are home to some of the most unique and mysterious ecosystems on Earth, and the closure of the oceans will eliminate many of these deep-sea habitats. However, new marine environments will form around the newly created mountain ranges and ocean basins. The rise of new land masses will create new habitats for marine life, with new coastlines and seas providing opportunities for species to adapt and evolve. As the oceans change, so too will the Earth's atmosphere. The distribution of land and sea influences the global climate, and as the oceans shift and change, the patterns of wind, precipitation and temperature will also change. The formation of a vast central supercontinent will likely create an area of extreme heat in the equatorial regions, while the lack of surrounding oceans will lead to more extreme temperature fluctuations in the interior of the landmass. These changes will likely lead to the formation of new deserts, forests and rainforests as the climate shifts in response to the new geography. The changing oceans of Pangea Proxima will also affect the global distribution of life. As the oceans close and new inland seas form, species will be isolated in different regions, leading to new evolutionary pressures. Life that currently thrives in the oceans will have to adapt to the new, more isolated environments, while terrestrial species will find new opportunities to spread and adapt to the changing geography. The changing oceans will be a key factor in the way life evolves in the future supercontinent. The changing oceans, then, will be one of the most significant aspects of the formation of Pangea Proxima. As the continents collide, the oceans will shrink, new seas will form, and the distribution of water across the Earth will be radically altered. The resulting changes in climate, ocean currents, and ecosystems will shape the future of the planet in ways that we can only begin to understand. The oceans, which have always been a key part of the Earth's identity, will become a new world, and the life that calls them home will adapt to the dramatic changes brought about by the forces of tectonic movement. As the Earth's tectonic plates continue their slow yet unstoppable dance, one of the most dramatic and visually striking features of Pangea Proxima will be the rise of new mountain ranges. These towering landforms, shaped by the collision and convergence of the Earth's continents, will forever alter the geography of the future supercontinent. Mountains, created by immense geological forces, will serve as the backbone of Pangea Proxima, affecting not only the physical landscape but also the climate, ecosystems, and the distribution of life. To understand how these new mountain ranges will form, we must first look at how mountains have been created throughout Earth's history. The process is complex and occurs over millions of years, but it can be boiled down to one fundamental mechanism: the collision of tectonic plates. When two plates collide, the crust is compressed, and this pressure causes the Earth's surface to buckle and fold. In some cases, one plate is forced beneath the other, creating a process called subduction, while in other cases both plates push upward, forming mountain ranges. The Himalayas, for example, were formed when the Indian plate collided with the Eurasian plate. As these two land masses converged, the crust was compressed and pushed upward, creating the towering peaks that we see today. The same process will be at work as Pangea Proxima begins to take shape. As the continents that currently exist begin to collide, the Earth's crust will undergo tremendous stress, causing it to buckle, fold, and rise. In the heart of the supercontinent, we will see vast mountain ranges emerge, much like the ones that currently define the world's most dramatic landscapes. mountain ranges such as the Andes, the Rockies and the Alps. But these new mountain ranges will be even more massive, as the collision of entire continents will create forces far more powerful than those we see today. One of the most significant collisions will occur between the African and European plates, which are slowly converging as the Atlantic Ocean shrinks. As these two continents collide, the crust will be compressed, and the result will be the rise of an enormous mountain range stretching across the northern part of Pangaea Proxima. This new range will be one of the most dominant features of the supercontinent, shaping the geography of the landmass and influencing the climate of the surrounding regions. The process of continental collision will create vast, towering peaks, and these mountains will act as barriers, dividing the supercontinent into different climate zones and creating new regions of extreme weather. Another major mountain range will form along the boundary between the Americas and Asia. As the Pacific Ocean closes and the Americas are pushed closer to Asia, the collision of the two land masses will create a new range that stretches across the western edge of Pangaea Proxima. This mountain range will likely be dominated by volcanic activity, as the subduction of the oceanic plates beneath the continental plates will lead to the formation of active volcanoes. The resulting volcanic mountain range will be rich in minerals and metals, and it will influence the climate of the surrounding regions, creating areas of intense rainfall and volcanic activity. In addition to these major mountain ranges, smaller ranges will also form as the continents collide. These smaller ranges will be scattered across the supercontinent, each one shaped by the unique interactions between the tectonic plates. In some cases, entire mountain chains will form as the plates push together, while in other cases, isolated mountains or mountain clusters will rise, creating a more fragmented landscape. These smaller ranges will play a significant role in shaping the local geography, influencing everything from wind patterns to the distribution of rainfall. One of the most striking aspects of the new mountain ranges of Pangaea Proxima will be their sheer size. These ranges will be much larger than anything we see today, stretching across vast distances and rising to even greater heights. The collision of entire continents will result in mountains that dwarf the tallest peaks on Earth today. Imagine a world where the Himalayas are no longer the tallest mountain range, but merely one of many towering ranges that stretch across the face of the supercontinent. The new mountain ranges will reshape the Earth's topography, creating a world that is much more rugged and dramatically varied than the one we know today. The formation of these new mountain ranges will also have a significant impact on the Earth's climate. Mountains act as natural barriers to the movement of air masses, and as these new ranges rise, they will influence the weather patterns across the supercontinent. In some regions, the mountains will block the flow of moist air, creating rain shadows and dry, arid conditions on the leeward side. In other areas, the mountains will capture moisture from the air, creating lush, rain-soaked regions on the windward side. These changes in climate will have a profound impact on the ecosystems that develop within Pangaea Proxima. The creation of mountains will also alter the flow of rivers and waterways. As the land rises, the rivers that currently flow across the continents will be forced to change course, carving new paths through the landscape. The collision of the continents will create new basins and valleys, and the rivers will adapt to these new features, flowing through newly created mountain ranges and shaping the land in ways that are difficult to predict. The formation of these new rivers and lakes will provide opportunities for new ecosystems to emerge, with species evolving to adapt to the changing environment. In addition to shaping the climate and ecosystems, the rise of new mountain ranges will also have a significant impact on the distribution of life. As the mountains create new barriers and regions of isolation, species will be forced to adapt to the new environments. Some species will thrive in the harsh, high-altitude conditions, while others will be pushed to new areas of the supercontinent. The changing geography of Pangaea Proxima will create new opportunities for evolution as species adapt to new mountain habitats, new food sources, and new climates. These adaptations will be driven by the forces of natural selection, and over time, the Earth's biodiversity will evolve in response to the changing landscape. The mountains of Pangea Proxima will also play a critical role in the carbon cycle. The formation of mountains through tectonic collisions and volcanic activity will release carbon dioxide into the atmosphere, influencing global temperatures and the Earth's climate. The weathering of rocks in the mountains will also absorb carbon dioxide, helping to regulate the planet's climate over long timescales. These geological processes will be an important part of the Earth's ongoing transformation, helping to balance the planet's climate and keep it habitable for life. As we look to the future of Pangea Proxima, it's clear that the rise of new mountain ranges will be one of the most transformative events in the history of Earth. These towering peaks will reshape the landscape, alter the climate, and create new environments for life to evolve. The forces that drive the formation of mountains, continental collision, subduction, and volcanic activity, are powerful and unstoppable, and they will continue to shape the Earth long into the future. The mountains of Pangea Proxima will stand as monumental testaments to the incredible forces that have shaped and will continue to shape our planet. And while we may never live to see them, the impact of these mountains will resonate throughout the future of life on Earth, creating a world that is both alien and familiar, shaped by the same geological forces that have been at work for billions of years. As the continents continue their inexorable drift toward each other, and Pangea Proxima begins to take shape, one of the most profound changes Earth will undergo is the shifting climate. The collision of vast land masses, the closing of oceans, and the formation of towering mountain ranges will all have a significant impact on the global climate. The world that emerges from this geological transformation will be vastly different from the Earth we know today. With new landforms, altered ocean currents, and the rise of massive supercontinents, the climate of Pangea Proxima will be shaped by the forces at play in ways that we can only begin to understand. To begin to grasp the full scope of these changes, we must first acknowledge the interconnectedness of Earth's systems. The climate is not just about temperature, it is also about the movement of air masses, the distribution of rainfall, and the way in which the oceans interact with the atmosphere. The formation of Pangea Proxima will disrupt many of these systems, leading to new weather patterns, temperature shifts, and the reorganization of ecosystems. From the vast central deserts to the humid coasts, the climate of this new supercontinent will reflect its geography, creating dramatic variations across different regions. One of the most immediate effects of Pangea Proxima's formation will be the shifting of ocean currents. As the Atlantic and Pacific Oceans close, new ocean basins will open, and the flow of water across the globe will change. Currently, the circulation of ocean water helps regulate the Earth's climate by transporting heat from the equator to the poles. The Gulf Stream, for example, carries warm water from the tropics to the North Atlantic, which in turn warms northwestern Europe. When the continents converge to form Pangea Proxima, the closure of the oceans will disrupt these ocean currents, leading to changes in how heat is distributed across the planet. With the new supercontinent positioned near the equator, the vast expanse of land will absorb more heat from the sun, increasing temperatures in the central regions. This will likely lead to the formation of massive deserts in the heart of Pangea Proxima. These deserts will be much larger than any we have today, stretching across the central parts of the supercontinent, with little to no rainfall. The intense heat in the interior will cause the air to rise, creating low-pressure areas that will draw moisture from the surrounding regions. As a result, the coasts will experience more precipitation, creating lush, temperate environments along the edges of the supercontinent in stark contrast to the arid centre. The movement of the tectonic plates, particularly the collision of the continents and the rise of mountain ranges, will also have a significant impact on the distribution of rainfall. Mountain ranges act as natural barriers to the movement of air masses. As moist air is forced up over the mountains, it cools and condenses, leading to heavy rainfall on the windward side. The leeward side, however, will experience a rain shadow effect, where dry air descends and creates arid conditions. This phenomenon will play a major role in shaping the climate of Pangea Proxima. The new mountain ranges will not only block air masses and affect rainfall patterns, but they will also divide the supercontinent into distinct climate zones, each with its own unique weather patterns. The rise of large mountain ranges will create new barriers that could separate warm, moist air from cooler, dry air, leading to extreme temperature fluctuations between the coastal regions and the interior. These mountains will play a critical role in determining where deserts, forests and other ecosystems will form. The landlocked regions in the heart of Pangaea Proxima, far from the moderating influence of the ocean, will experience extreme temperature shifts, with scorching heat during the day and freezing temperatures at night. In contrast, the coastal regions will benefit from the moderating effects of the ocean, leading to more temperate conditions and more stable climates. As the continents collide and the supercontinent begins to form, the closure of the oceans will also have an impact on the carbon cycle. Oceans are key players in regulating the Earth's climate by absorbing and releasing carbon dioxide, a greenhouse gas that helps to regulate global temperatures. With the shrinking of the oceans, the Earth will lose one of its primary mechanisms for regulating atmospheric carbon levels. At the same time, the collision of the continents will release carbon stored in the Earth's crust through volcanic activity. This volcanic activity, particularly in the regions where plates are subducted, will release large amounts of carbon dioxide into the atmosphere, contributing to a rise in global temperatures. The buildup of carbon dioxide in the atmosphere will likely intensify the greenhouse effect, further warming the Earth. This will create a feedback loop, where rising temperatures lead to more intense weather patterns, which in turn release more greenhouse gases into the atmosphere. The warming will be particularly pronounced in the central regions of Pangea Proxima, where the vast landmass will absorb and retain heat. This will lead to hotter summers, more intense droughts, and extreme temperature swings in the interior of the supercontinent. The climate will be harsh, and life will have to adapt to these extreme conditions. The changing climate of Pangea Proxima will also have profound effects on the ecosystems of the supercontinent. With the formation of vast deserts in the interior and the shifting of ocean currents, the distribution of rainfall will change dramatically. The wet coastal regions will support diverse ecosystems, but the interior deserts will be much more sparsely populated, with only the hardiest species able to survive. The changing weather patterns will force species to adapt or migrate, and over time, the Earth's biodiversity will evolve to match the new climate. Some species will thrive in the warm, moist coastal environments, while others will adapt to the harsh, dry conditions in the interior. The formation of Pangea Proxima will also create new oceanic environments that will further alter the climate. As new seas form within the supercontinent, they will create localized weather patterns and influence the climate of the surrounding regions. These inland seas will have a moderating effect on the temperature, creating more temperate conditions in their immediate vicinity, but they will also be subject to extreme temperature variations due to their isolation from the ocean currents. The climate around these inland seas will be unique, with the potential for both wet and dry conditions, depending on the distribution of heat and moisture in the surrounding areas. The global climate will not only be affected by the landforms and oceanic changes, but also by the way in which the Earth's atmosphere interacts with the surface. The formation of new mountains and the shifting of air masses will lead to new wind patterns, which will affect everything from rainfall to the distribution of heat across the planet. As the supercontinent grows, the atmospheric circulation will shift to reflect the new geography. These changes in wind patterns will further contribute to the reshaping of ecosystems, pushing species into new territories and creating new niches for life to fill. The climate of Pangea Proxima will be vastly different from the world we live in today. The distribution of land and water, the rise of new mountain ranges, the closure of oceans, and the shifting of ocean currents will all work together to create a new climate that is both harsher and more diverse than anything we know today. From the extreme heat of the interior deserts to the temperate coasts and the shifting weather patterns brought on by the collision of continents, the climate of Pangea Proxima will be a product of the same slow, but powerful geological forces that have shaped Earth's climate throughout its history. While the exact details of Pangea Proxima's climate remain speculative, it's clear that the forces of tectonic activity, combined with the rearranging of the Earth's oceans and land masses, will create a world that is both familiar and foreign. The shifting climate will alter ecosystems, forcing species to adapt, migrate, or face extinction. As the continents collide and the supercontinent emerges, the Earth will enter a new chapter in its ongoing geological and climatic transformation, one that will shape the future of the planet for millions of years to come. As the continents converge and the supercontinent of Pangea Proxima begins to take shape, the landscapes that currently support the diverse ecosystems of Earth will undergo dramatic changes. The merging of vast land masses, the closing of oceans, and the formation of towering mountain ranges will not only reshape the Earth's geography, but will also result in the loss of many habitats that species today rely on. The shifting of continents and the reorganization of ecosystems will create new environments, but it will also force many species to adapt or perish. The loss of habitats is an inevitable consequence of the Earth's ongoing tectonic activity, and it is a challenge that will force life on Earth to evolve in ways that are difficult to predict. The most immediate and striking consequence of the formation of Pangea Proxima will be the disappearance of the vast oceans that currently separate the continents. The Atlantic Ocean, which today separates the Americas from Europe and Africa, will close as the tectonic plates converge. As the ocean shrinks, the ecosystems that depend on it, the coastal wetlands, the coral reefs, and the deep ocean habitats, will be lost. The Pacific Ocean, the largest and deepest of the world's oceans, will also shrink as it is subducted beneath the surrounding plates.
The closure of these oceans will eliminate some of the most biodiverse ecosystems on Earth, and species that rely on these habitats for food, shelter, and migration will face extinction or be forced to adapt to entirely new environments. The loss of marine habitats will be particularly significant. Oceans are home to a vast array of species, many of which have evolved to thrive in their specific environments. Coral reefs, often referred to as the rainforests of the sea, support more marine life than any other ecosystem on Earth. As the oceans close and the Earth's geography shifts, the coral reefs will be left stranded, unable to survive in the new, less hospitable environments. The loss of these vital habitats will have ripple effects throughout the marine food chain, affecting everything from tiny plankton to large predatory fish. The creatures that depend on the oceans will need to find new ways to survive, and many will not be able to adapt quickly enough. In addition to the loss of marine habitats, the collision of the continents will lead to the destruction of terrestrial ecosystems as well. As the continents come together, vast stretches of land will be pushed into one another, causing the land to rise and form massive mountain ranges. These mountain ranges, while creating new habitats in some areas, will also create barriers that divide ecosystems and isolate species.
Species that once roamed across large areas will be confined to smaller regions, and the fragmentation of habitats will limit their ability to migrate and find food. Species that thrive in flat, low-lying areas will be forced to adapt to the rugged, high-altitude environments created by the rising mountains, or they will face extinction. The creation of large inland seas within the supercontinent will also contribute to the loss of habitats. These seas will be isolated from the world's oceans, creating unique ecosystems, but also limiting the biodiversity that can thrive within them. The lack of open water and the extreme temperature variations in these inland seas will create inhospitable conditions for many species. The rise of deserts in the central regions of Pangea Proxima will also create new challenges for life. The vast arid expanses, cut off from the moderating influence of the oceans, will become harsh environments where only the most resilient species can survive. Species that once lived in the temperate regions of the Earth will be forced to adapt to the extreme conditions of the new supercontinent or find refuge in the more hospitable coastal regions. One of the most profound impacts of the formation of Pangea Proxima will be the loss of the familiar ecosystems that have evolved over millions of years. The tropical rainforests, the grasslands, the savannas, and the temperate forests that currently exist will be reshaped by the collision of continents.
As the landmasses come together, new mountain ranges will block air and ocean currents, leading to changes in precipitation patterns. Some regions will become much wetter, while others will become drier. The loss of these habitats will be particularly challenging for species that rely on specific climatic conditions. The tropical rainforests, for example, are home to an incredibly diverse array of species, many of which are found nowhere else on Earth. As the climate shifts and the land masses collide, the forests will be displaced, and the species that call them home will have to adapt or face extinction. The loss of habitats will not only affect the physical environments in which species live, but it will also have a profound impact on the behavior and survival of species. As the continents converge, species that were once separated by oceans will find themselves in direct competition for resources. This will lead to new pressures on species as they struggle to find food, shelter, and mates in the newly formed ecosystems. Species that were once adapted to specific habitats will have to evolve quickly to cope with the changing environments, and many will not be able to keep up with the rapid pace of change. The loss of habitats will also disrupt migration patterns, as species that once migrated across continents will be confined to smaller fragmented regions.
The loss of habitats will be particularly challenging for the planet's most vulnerable species, those that are already at risk due to habitat destruction, climate change, and human activity. As Pangea Proxima forms, these species will face new threats as their habitats disappear, and they will be forced to adapt to a world that is constantly changing. For some species, the changes may be too great, and they will face extinction. For others, the formation of Pangea Proxima will provide an opportunity to evolve and adapt to the new environments. Over time, the biodiversity of the supercontinent will shift, as new species emerge to fill the ecological niches left by those that went extinct. The process of evolution, driven by the changing geography and climate, will continue to shape life on Earth, leading to the rise of new ecosystems and the extinction of others. In many ways, the loss of habitats will be a natural part of the Earth's ongoing geological and biological processes. Just as the breakup of Pangaea led to the formation of new habitats and the diversification of life, the formation of Pangaea Proxima will also lead to the creation of new ecosystems. But this process comes at a cost. The destruction of existing habitats and the extinction of species will be a tragic consequence of the changes brought about by tectonic activity. However, the loss of habitats is not the end of the story. It is a part of the ongoing cycle of life on Earth, one that is shaped by the slow, steady forces of nature, and one that will continue to unfold as the planet's continents collide and reshape the world once more. The loss of habitats in Pangea Proxima will be a reminder of the fragility of life on Earth. As the continents merge and the landscape transforms, species will face new challenges and opportunities. The habitats that have supported life for millions of years will be lost, but new ones will emerge, and life will continue to adapt and evolve. It is this constant process of change and adaptation that has driven the evolution of life on Earth for billions of years, and it will continue to shape the future of the planet long after the formation of Pangea Proxima. As the continents move and collide, and as the Earth's surface reshapes itself over the course of millions of years, the dramatic forces at work beneath the surface will result in a host of natural wonders. Among the most powerful and awe-inspiring of these will be earthquakes, volcanoes, and other geologic phenomena, all of which will play a crucial role in shaping the geography and climate of Pangea Proxima. These events, driven by the same tectonic forces that push the continents together, will create a dynamic and ever-changing Earth. The landscape of Pangea Proxima will not be one of static landforms, but rather a land of constant movement, where the Earth itself seems alive, shifting and transforming in response to the forces beneath. To understand the full impact of these geological events, we need to look at the processes that drive them. Earthquakes, for example, occur when stress builds up along fault lines in the Earth's crust. This stress is created by the movement of tectonic plates, which are constantly shifting and colliding. As the plates move, they can become locked together at the boundaries, preventing further movement. Over time, the stress builds up until it is released in a sudden, powerful burst of energy, causing the ground to shake. Earthquakes are most common along fault lines, particularly at convergent and transform boundaries, where plates are either colliding or sliding past each other. In Pangaea Proxima, the collision of the continents will create numerous fault lines and areas of intense seismic activity. As the land masses converge, the stress on the Earth's crust will increase, leading to more frequent and more powerful earthquakes. These seismic events will not only shake the land but will also contribute to the rise of mountains, the opening of new fault lines, and the destruction of older landforms. The new supercontinent will be a place of constant tectonic activity, where the Earth's surface is continually reshaped by the powerful forces of nature. Volcanic activity will be another defining feature of Pangea Proxima. Volcanoes are created when molten rock from the Earth's mantle, known as magma, rises to the surface and erupts. This process occurs primarily at divergent and convergent plate boundaries, where tectonic plates either pull apart or collide. As the plates move, magma from the mantle can rise through cracks in the Earth's crust, creating volcanoes. In some cases, these volcanoes are created by the subduction of one plate beneath another, where the descending plate melts and forms magma that escapes to the surface. In other cases, the formation of volcanoes is driven by the pulling apart of tectonic plates, which creates rift zones and allows magma to escape. In Pangea Proxima, volcanic activity will be widespread, particularly in the areas where the plates converge and where the land is being pushed upward.
These volcanic zones will create new mountain ranges, like the Andes and the Himalayas of today, but on an even grander scale. As the continents collide and push against one another, immense volcanic mountains will rise, reshaping the landscape of the supercontinent. The volcanic activity will also have a profound impact on the climate, as the eruptions will release large amounts of ash and gases into the atmosphere. These materials will block sunlight, causing short-term cooling of the Earth's surface, while the release of carbon dioxide will contribute to long-term warming. The presence of volcanoes will make Pangea Proxima a place of intense geological activity, where the Earth's crust is constantly being reshaped by the forces beneath. The natural wonders of Pangea Proxima will not only be limited to earthquakes and volcanoes. The collision of the continents will create new mountain ranges, vast valleys, and deep ocean basins, all of which will be shaped by the relentless forces of plate tectonics. The rising mountains in particular will create dramatic new landscapes, with towering peaks, deep valleys, and vast plateaus. These new mountains will block air and ocean currents, altering the climate and creating distinct weather patterns. The central regions of the supercontinent will likely be dominated by arid deserts and high-altitude plateaus, while the coasts will experience more temperate conditions with lush forests and fertile soils. One of the most striking features of Pangea Proxima will be the formation of large rift zones. These rift zones, where tectonic plates are pulling apart, will create new bodies of water, new seas, and new landscapes. As the plates continue to move, the rift zones will widen and the land between them will sink, forming new oceans or large inland seas. These rift zones will be areas of intense volcanic activity, with lava pouring from the Earth's crust and creating new land. The presence of these rift zones will make Pangea Proxima a land of constant geological transformation, where new land masses and water bodies emerge on a regular basis. The shifting of tectonic plates will also contribute to the formation of deep ocean trenches, similar to the Mariana Trench in the Pacific Ocean. These trenches are created when one tectonic plate is subducted beneath another, forming deep, narrow depressions in the ocean floor. In Pangaea Proxima, the closing of the oceans and the subduction of oceanic plates will create new ocean trenches, further reshaping the Earth's surface. These deep trenches will serve as important ecosystems, providing habitats for unique marine life and influencing ocean currents and the distribution of heat across the planet. The combination of earthquakes, volcanoes, rift zones, and ocean trenches will make Pangaea Proxima a dynamic and ever-changing world.
The forces of plate tectonics will shape the landscape, create new natural wonders, and transform the Earth's climate. These natural wonders will be both awe-inspiring and dangerous, as the powerful forces at work beneath the Earth's surface create dramatic shifts in the planet's geography. But while these events may seem destructive, they are also essential to the continued evolution of the Earth. They are the engines that drive the planet's transformation, creating new landforms, new ecosystems, and new opportunities for life to evolve. As we imagine the future of Pangaea Proxima, we must recognise that the Earth is a dynamic, ever-changing planet. The natural wonders that will arise from the collision of continents and the shifting of tectonic plates will be a testament to the power of the forces that drive the Earth's evolution. From the rise of volcanic mountains to the rumble of earthquakes, these events will shape the world of tomorrow, creating a landscape that is both alien and familiar. The natural wonders of Pangaea Proxima will not just be geological curiosities, they will be the foundation of a new world, one that will continue to evolve and transform in response to the forces beneath our feet. And in this ever-changing world, life will adapt, survive, and thrive in ways that we can only begin to imagine. As the formation of Pangaea Proxima progresses, the Earth will experience a dramatic reorganization of its climate zones, with vast regions being dominated by deserts in the interior and glaciers at the poles. The collision of continents, the rise of immense mountain ranges, and the reshaping of the planet's oceanic and atmospheric systems will create environments far more extreme than those found on Earth today. This new supercontinent will be divided by expansive deserts and vast glaciers, and the dramatic contrast between these two features will define the landscape of Pangaea Proxima. One of the defining features of Pangaea Proxima will be the massive arid deserts that stretch across the heart of the supercontinent. The central landmass of the new supercontinent, located near the equator, will experience intense heat and dryness. As the supercontinent grows, the absence of surrounding oceans will leave the interior regions exposed to extreme temperature fluctuations. The lack of moisture in the air, coupled with the distance from the moderating effects of the oceans, will create vast deserts where rainfall is scarce, and the temperature swings between scorching heat during the day and freezing cold at night. These deserts will be far larger and more expansive than any we see today. The vast, dry expanses will stretch across the interior of Pangaea Proxima, possibly extending from one side of the supercontinent to the other.
The lack of oceanic influence will result in very low humidity levels, and the absence of large bodies of water will make it difficult for moisture to accumulate in the air. The deserts of Pangaea Proxima will not only be inhospitable to human life, but will also present challenges for the species that evolve in this harsh environment. The plant and animal life in these deserts will be highly specialized, adapting to the extreme conditions in ways that may seem alien to us. These deserts will have a profound impact on the distribution of life across Pangaea Proxima. Species that are adapted to desert life today, such as camels, cacti, and other hardy organisms, will likely be present in the future supercontinent. However, they will evolve to cope with even more extreme conditions than those we find in modern deserts. These adaptations will include unique strategies for conserving water, surviving temperature extremes, and finding food in an environment where resources are limited. The species that thrive in these deserts will be those that are able to withstand the relentless heat and aridity, possibly through physiological adaptations that allow them to store moisture, regulate body temperature, or endure long periods of drought. The division between the deserts and the more temperate coastal regions of Pangaea Proxima will be stark. The coasts, while still far from the stabilizing influence of the oceans we know today, will likely be more temperate, with more stable climates and more regular rainfall. The formation of inland seas and new bodies of water within the supercontinent will further contribute to the moderation of the climate along the coast. These coasts will experience milder temperatures, which will create more favorable conditions for life to flourish. Coastal rainforests, grasslands, and forests may begin to develop in the more temperate zones, forming diverse ecosystems that contrast sharply with the vast, dry deserts that dominate the interior. The movement of the tectonic plates will also create new mountain ranges that run along the edges of the supercontinent, acting as barriers to the movement of air masses and further influencing the climate of Pangaea Proxima. These mountains will disrupt the flow of moist air from the oceans, causing precipitation to be concentrated in the areas where the air rises over the mountains. As a result, the windward side of these mountain ranges will experience higher levels of rainfall, while the leeward side will experience drier conditions, contributing to the formation of deserts. These mountain ranges will divide the supercontinent into different climatic regions, creating further contrast between the arid interior and the wetter coastal zones.
In addition to the vast deserts, Pangaea Proxima will also experience the expansion of glaciers at the poles. As the supercontinent takes shape and the Earth's geography changes, the polar regions will become more extreme, with glaciers advancing and retreating as the climate fluctuates. The absence of large oceans will mean that the heat distribution across the Earth will be more uneven, with the polar regions becoming significantly colder. The glaciers of Pangaea Proxima will be far more expansive than those of today, possibly covering large portions of the supercontinent's northern and southern edges. These glaciers will reshape the landscape, carving out new valleys, fjords, and mountain ranges as they advance and retreat over time. The formation of glaciers will have a significant impact on the global climate. Glaciers reflect sunlight back into space, which helps to cool the planet, but they also contribute to rising sea levels when they melt. The growth of glaciers in Pangaea Proxima will increase the Earth's albedo effect, potentially cooling the planet even further. However, as the glaciers melt, they will release large amounts of fresh water into the oceans, causing sea levels to rise and contributing to changes in ocean circulation patterns. The melting of the glaciers will also create temporary periods of warming, as the release of water vapour from the ice can trap heat in the atmosphere. These fluctuations in temperature and sea levels will further contribute to the shifting climate of the supercontinent. As the glaciers advance and retreat, they will also influence the ecosystems of Pangaea Proxima. Species living in the polar regions will need to adapt to the harsh, cold conditions of the glaciers, while those in the warmer regions will be forced to migrate in response to the changing climate. These shifts in climate will create a dynamic, ever-changing world where the boundaries between deserts, forests, and glaciers are constantly shifting. The forces of plate tectonics and the resulting changes in geography will create new opportunities for life to evolve and adapt, but they will also lead to the extinction of species that cannot cope with the rapidly changing environments. The interaction between the deserts and glaciers will define much of the climate of Pangaea Proxima. As the supercontinent forms, the temperature difference between the hot, dry interior and the cold, glaciated poles will become more pronounced. The result will be the development of extreme weather patterns, with violent storms, dramatic temperature shifts, and unpredictable rainfall. The formation of deserts and glaciers will create stark contrasts in the global climate, with some regions experiencing intense heat, while others are locked in an eternal winter.
These extreme conditions will push species to evolve in unique ways, creating new adaptations to survive the harsh environments of Pangaea Proxima. The climate of Pangaea Proxima will be one of extremes, of scorching deserts and freezing glaciers, shaped by the collision of continents, the rise of mountains, and the retreat of oceans. The supercontinent will be a land of contrasts, where the heat of the interior deserts is balanced by the cold of the polar glaciers. These extremes will create new challenges for life, pushing species to adapt to an ever-changing world. Yet even in the face of such dramatic shifts in the Earth's climate, life will continue to evolve, adapting to the new habitats and climate zones created by the shifting geography. The landscapes of Pangea Proxima, divided by deserts and glaciers, will be a testament to the power of nature and the constant cycle of change that shapes our planet. As the continents collide to form Pangea Proxima and the Earth's geography and climate undergo profound shifts, life on the planet will be forced to adapt to an ever-changing environment. The collision of continents, the rise of mountain ranges, the loss of familiar habitats, and the creation of vast deserts and glaciers will all lead to the rise of new life forms. This new world will provide both challenges and opportunities for evolution. And as old species adapt or fade away, new ones will emerge to fill ecological niches that were once unoccupied. Pangaea Proxima will be a planet of transformation, where the forces of nature will drive the evolution of life in ways that are as dramatic and unpredictable as the tectonic events that shape the land. The first major factor influencing the rise of new life forms will be the dramatic shifts in climate. The harsh interior deserts, vast oceans, and cold polar regions of Pangaea Proxima will create extreme temperature gradients and radically different environmental conditions across the supercontinent. These climate extremes will create new selective pressures for species, forcing them to adapt to their new environments. Species that are unable to cope with the harsh conditions will face extinction, while those that can withstand the heat of the deserts or the cold of the glaciers will evolve new adaptations that allow them to survive.
In the arid deserts of Pangea Proxima, for example, life will have to evolve to cope with extreme heat, water scarcity, and dramatic temperature fluctuations. The animals and plants that thrive in these regions will likely develop new strategies for conserving moisture, such as specialized adaptations for storing water or minimizing water loss. The plants in the desert will develop more efficient photosynthesis systems, possibly evolving to capture and store water for long periods. Animals will likely develop thicker skins or unique behaviors to conserve body heat and stay hydrated. These desert-dwelling life forms will become more specialized and resilient, thriving in an environment where the conditions are harsh and survival depends on finding innovative ways to adapt to the ever-changing climate. The development of new mountain ranges will also lead to the emergence of new species. The rising peaks will create isolated ecosystems, where species that were once part of larger populations will become confined to smaller, more fragmented regions. These isolated populations will face a different set of selective pressures. The physical isolation caused by the mountains will lead to allopatric speciation, where new species evolve to fill the ecological niches that exist in the mountains' unique environments.
The harsh, high-altitude conditions, such as lower oxygen levels, colder temperatures, and intense weather patterns, will drive the evolution of animals and plants that are specialized to survive in these extreme environments. The coastal regions of Pangea Proxima will also be a focal point for the rise of new life forms. These areas, though still subject to dramatic temperature swings and fluctuating climates, will be more temperate and better suited to support a wider range of species. The presence of inland seas and the reshaping of the Earth's water systems will lead to the development of new aquatic ecosystems. Freshwater species that evolve in these new bodies of water will adapt to the specific conditions of their environments. Fish, amphibians, and other aquatic life forms will undergo rapid diversification, adapting to new water temperatures, salinity levels, and food sources. The creation of inland seas, isolated from the larger oceans, will also lead to the evolution of species that are specially adapted to these contained environments. These bodies of water will serve as incubators for the development of new forms of life, as species become isolated and evolve independently from their oceanic relatives. The absence of oceanic currents and the unique chemical compositions of the inland seas will create novel environments for aquatic species, which will adapt to the specific conditions of these inland waters.
The new aquatic life forms will become just as specialized as their desert counterparts, adapting to the unique challenges presented by their isolated environments. The changing atmosphere, driven by the movement of tectonic plates and the volcanic activity that will be prevalent during the formation of Pangea Proxima, will also influence the evolution of life. The release of gases like carbon dioxide and sulfur from volcanic eruptions will affect the composition of the atmosphere, potentially increasing the greenhouse effect and leading to warmer global temperatures. Species that rely on specific atmospheric conditions such as oxygen levels or specific temperature ranges will either need to adapt to the changing environment or face extinction. The rise in carbon dioxide could spur the development of new plant life, with some species evolving more efficient methods of photosynthesis to take advantage of the higher levels of the gas. The Earth's plant life will adapt to the changing conditions, giving rise to new forms of vegetation that are capable of thriving in a warmer, more carbon-rich atmosphere. The rise of new life forms will not be limited to land and water species. The constantly changing geography of Pangea Proxima will also create new opportunities for microbial life to thrive.
The shifting of the continents and the reconfiguration of the oceans and inland seas will create new environments for microbes to adapt to, and their rapid rate of reproduction and mutation will lead to the quick emergence of new strains. These microbes will be the pioneers of life in the New World, adapting to the changing environments of Pangea Proxima and driving the evolution of larger organisms. The presence of new microbial life will shape the future of ecosystems, as these organisms form the foundation of the food chain and influence the development of more complex life forms. As Pangea Proxima forms, the loss of some species and the rise of new life forms will be part of the natural course of evolution. The dramatic shifts in climate, geography, and ecosystems will drive species to adapt, migrate, or evolve new traits that allow them to survive in their changing environments. Just as Pangaea's breakup led to the diversification of life in the current continents, the creation of Pangaea Proxima will lead to new waves of evolution, driven by the challenges and opportunities presented by the new supercontinent. Over time, the supercontinent will become a place of astonishing biodiversity, filled with creatures that are unlike anything we see today. Life on Pangea Proxima will adapt to the extremes, from the scorching heat of the deserts to the freezing cold of the glaciers.
The animals, plants, and microorganisms that evolve in this new world will be shaped by the forces of nature that drive the Earth's ongoing transformation, creating ecosystems that are as diverse and complex as the forces that gave birth to them. The rise of new life forms in Pangea Proxima will be a testament to the resilience of life on Earth. Even in the face of dramatic environmental changes, life will continue to adapt and evolve, filling the newly formed habitats and ecosystems that emerge. While some species will disappear, others will thrive, and the future of life on Earth will be written in the landscapes of the supercontinent. The story of evolution will continue, and the rise of new life forms will mark the beginning of a new chapter in the history of our planet.
As Pangea Proxima begins to emerge from the slow but inevitable process of continental drift, one of the most dramatic and far-reaching changes will be the reconfiguration of the Earth's oceans and their currents. The collision of continents, the closing of oceans, and the rising of new landmasses will disrupt the patterns of ocean circulation that have existed for millions of years, leading to the development of new ocean currents that will have profound effects on the global climate, ecosystems, and the distribution of life. Today, ocean currents play a vital role in regulating Earth's climate by transporting heat, moisture, and nutrients around the globe. These currents, driven by wind patterns, the rotation of the Earth, and differences in water temperature and salinity, help to moderate temperatures, support marine ecosystems, and influence weather patterns. As the continents shift, however, the very structure of the Earth's oceans will change, and new currents will emerge in response to the altered geography of Pangea Proxima. The global oceanic circulation will be fundamentally transformed, creating new patterns of heat distribution, weather, and nutrient flow that will shape the future of life on Earth. One of the most immediate effects of the formation of Pangaea Proxima will be the closure of the Atlantic and Pacific Oceans. As these oceans shrink and are eventually replaced by smaller seas and new rift zones, the balance of oceanic circulation will shift.
The Atlantic Ocean, which currently plays a key role in transporting warm water from the equator to the higher latitudes, will be replaced by a narrow inland sea running through the centre of Pangaea Proxima. This new sea will have a profound impact on the distribution of heat across the supercontinent, as it will no longer be able to circulate warm water between the Americas and Europe or Africa. The absence of the Atlantic will disrupt the Gulf Stream, which carries warm water from the tropics to the North Atlantic, and the entire system of thermohaline circulation will be altered. The formation of new mountain ranges, particularly those that will emerge along the converging edges of the continents, will also play a critical role in the development of new ocean currents. Mountain ranges, especially those that span large areas of land, act as physical barriers to wind and water movement. As these mountains rise, they will alter the flow of ocean currents, causing them to shift and change course. On the windward side of these mountains, warm, moist air will rise and cool, creating new patterns of rainfall and altering the ocean currents below. On the leeward side, the air will descend and become drier, creating new regions of aridity and further disrupting the flow of currents. These changes in ocean circulation will have far-reaching effects on the climate of Pangaea Proxima, as the redistribution of heat and moisture will create new patterns of rainfall, temperature, and seasonal weather. The new geography of the oceans will also affect the distribution of nutrients in the water. Today, the mixing of ocean waters through currents is essential for bringing nutrients from the deep ocean to the surface, where they support marine life. This upwelling of nutrients is driven by the movement of water at the surface and the interaction of ocean currents with the sea floor. As the continents collide and new oceanic basins are formed, the flow of water will change, and the nutrient dynamics will be altered. Some areas of the ocean may experience greater upwelling, leading to an increase in biological productivity and the flourishing of marine life. Other areas, however, may become more isolated, as the new currents may prevent the mixing of waters, leading to nutrient-poor regions where marine life struggles to thrive. The closure of the Pacific Ocean will also have a profound effect on the flow of water between the Americas and Asia. As these two continents collide, the narrowing of the ocean will force the water to move more rapidly, creating strong currents that will shape the new coastal regions of Pangaea Proxima.
The shallow seas that will form between the newly connected land masses will create ideal conditions for the development of new marine ecosystems, while the disruption of the Pacific's currents will alter the climate of both the Americas and Asia. The warming effects of the Pacific's currents will no longer reach the coasts of the Americas, and the cooling influence on Asia will also diminish. This will lead to more extreme temperature fluctuations along the western coasts of the Americas and the eastern coasts of Asia. The formation of the new supercontinent will also result in the creation of new oceanic rift zones. These rift zones, where tectonic plates are pulling apart, will open up new channels of water and create new ocean basins. These rift zones will become major contributors to the circulation of ocean currents, as they allow for the mixing of deep ocean water with surface water, bringing nutrients and heat to new regions. The shifting of the ocean basins will lead to new interactions between oceanic currents and atmospheric patterns, altering the way that water and air move across the planet. As these new currents develop, they will create new patterns of heat distribution, which will influence the climate and ecosystems of Pangaea Proxima. In addition to the changes in oceanic circulation, the redistribution of water will also have an impact on sea level. The closing of the oceans and the formation of new seas and rift zones will cause the global sea level to fluctuate. As the land masses of Pangea Proxima converge and rise, vast areas of ocean will be displaced, leading to the creation of inland seas and new shorelines. These changes in sea level will have a significant impact on coastal ecosystems as new coastlines form and old ones are submerged. The species that depend on coastal habitats will need to adapt to these changing environments, either by migrating to new areas or evolving to thrive in the altered ecosystems. New habitats will emerge, and life will adapt to these new regions, just as it has done throughout Earth's history. The changing ocean currents and shifting geography of Pangea Proxima will also have an impact on the Earth's weather patterns. The movement of warm and cold water through the oceans is a key driver of atmospheric circulation, and the reorganization of the oceans will lead to the creation of new weather systems. Areas that once experienced mild temperate climates will become hotter and drier, while regions that were once dry will become wetter. The distribution of rainfall will be altered, with some areas becoming more prone to flooding, while others will experience prolonged droughts. These shifts in weather patterns will create new challenges for the species that live on the supercontinent, forcing them to adapt to new environments and new conditions. The oceans of Pangea Proxima will not only be shaped by the collision of continents and the rise of new landforms, but will also influence the evolution of life on Earth. The reconfiguration of ocean currents, the mixing of water, and the redistribution of nutrients will create new opportunities for marine life to thrive, while also pushing species to evolve in response to the changing conditions. The new currents will serve as highways for migration, allowing species to spread across the supercontinent's oceans, while also creating new barriers that isolate populations and drive speciation. As the oceans change, so too will life within them, leading to the rise of new forms of marine life that are adapted to the altered environments of Pangea Proxima. The new currents of Pangea Proxima will be a defining feature of the supercontinent, driving the movement of heat, moisture, and nutrients around the globe. These currents will shape the climate, influence the weather, and determine the distribution of life across the planet. As the continents collide and the oceans shrink, the currents of Pangea Proxima will create a dynamic, ever-changing world where the forces of nature continue to shape and reshape the Earth's environment. The new oceanic circulation will be one of the most important factors in determining the future of life on the supercontinent, as species adapt to the changing currents, climates, and ecosystems that emerge.
The oceans of Pangea Proxima will be the lifeblood of the supercontinent, driving the evolution of life and shaping the world for millions of years to come. As the tectonic plates continue to move and the continents converge, the world that we know today will eventually fade into the distant past. The familiar land masses of North and South America, Europe, Africa, Asia, and Australia will no longer exist in their current form. The end of the present-day continents marks a monumental shift in Earth's geological history, one that will redefine the planet's geography and the very fabric of life that it supports. The formation of Pangea Proxima will signal the ultimate conclusion of today's continents, as they are consumed, altered, and incorporated into a new supercontinent, reshaping the course of life for millions of years to come. At the heart of this transformation is the relentless movement of tectonic plates, driven by the forces of mantle convection, slab pull, and ridge push. Over millions of years, the land masses we know today will be drawn together by these tectonic forces. Oceans will close, and the once separated continents will begin to merge. As this process unfolds, the familiar coastlines of the modern world will gradually disappear, swallowed by the advancing collision of land masses. As the continents are pulled together, their shapes will no longer be recognizable. They will be broken apart, fused, and redistributed across the face of the Earth. The first of the modern continents to meet their fate will be those along the edges of the supercontinent. Africa and Europe will collide with the Americas, bringing together what were once distant shores. The Mediterranean Sea, which currently separates Europe and Africa, will close as the two land masses collide, forming a massive land bridge between them. The collision will result in the rise of enormous mountain ranges, perhaps even larger than the Himalayas, as the tectonic plates of Africa and Europe push against the Americas. These mountains will create a new geography, with the familiar coastlines of the Atlantic Ocean giving way to a new, more interconnected landmass. The Atlantic Ocean, which has long separated the Americas from Europe and Africa, will shrink and ultimately close as the tectonic plates beneath the ocean are pushed downward into the mantle. The process of subduction will gradually swallow the ocean floor, pushing the continents closer together. The land masses that were once separated by vast oceans will be drawn into a single supercontinent, their familiar coastlines blending into a new world. In the process, the ecosystems that once flourished along the coast will be transformed, as the collision of continents will create new, often harsh environments. The species that currently inhabit these coastal regions will face extinction or be forced to adapt to new habitats. As the Pacific Ocean also begins to shrink, the Americas will be pulled closer to Asia. The Pacific, once the largest and deepest of Earth's oceans, will be swallowed by the converging plates. The collision between the Pacific and the surrounding land masses will create mountain ranges along the western edges of the Americas and Asia. These ranges will be rich in volcanic activity, as subduction zones generate intense geological forces, resulting in the formation of new volcanic chains and the rise of new mountains. The eastern coasts of Asia and the western coasts of the Americas will be transformed by the collision, with new landforms emerging from the tectonic chaos. The eventual closure of the Pacific will also mean the end of the unique ecosystems that thrive in its vast waters. The coral reefs of the Pacific, which are home to some of the most biodiverse marine life on Earth, will be displaced as the ocean disappears. These marine ecosystems will be replaced by new environments formed by the rising land masses and changing currents. Marine life will adapt to these new conditions, but the once diverse ecosystems of the Pacific will be lost. The transformation of the Pacific Ocean into a narrower body of water will lead to the rise of new inland seas and a complete reorganization of the world's oceans. The closure of the Pacific and the Atlantic Oceans, along with the merging of the continents, will result in a new world of interconnected land masses. The familiar map of the modern continents will be unrecognizable as the continents are fused into a new supercontinent. Pangea Proxima will have its own unique geography, formed by the collision of the Americas, Europe, Africa, Asia, and the remaining land masses. The central portion of the supercontinent will be dominated by massive inland seas and deserts, while the coastal regions will experience more temperate climates due to the moderating effects of the oceans. New mountain ranges will rise, creating dramatic landscapes and shaping the climate and ecosystems of the supercontinent. As the modern continents come to an end, so too will the familiar ecosystems that have evolved over millions of years. The plant and animal species that currently inhabit Earth's diverse landscapes will face unprecedented challenges. Species that are adapted to the climates and environments of today's continents will struggle to survive as the climate shifts and new landforms emerge. The mass extinction events that often accompany major geological transformations will occur, with many species unable to adapt quickly enough to the changing world. However, in the wake of this extinction, new species will evolve to fill the niches left behind, creating a world of life that is both familiar and entirely new. The end of the current continents will also mark the end of familiar ecosystems and climates. The forests, grasslands, deserts, and oceans that have shaped life on Earth will be replaced by new environments that are influenced by the rising mountains, shrinking oceans, and shifting climate. The once distinct ecosystems of the continents, such as the Amazon rainforest, the Sahara Desert, and the Great Barrier Reef, will be transformed as the land masses merge. New forests will rise in the temperate regions, while the deserts will grow larger and more arid in the centre of Pangea Proxima. New aquatic ecosystems will emerge in the inland seas, while the open oceans will be replaced by smaller, more isolated bodies of water. The disappearance of the current continents and the rise of Pangea Proxima will be a defining moment in Earth's history. The continents that have shaped life for millions of years will be gone, replaced by a new supercontinent that will shape the course of life for millions more. The tectonic forces that have driven the breakup of Pangaea, the formation of continents, and the creation of new landscapes will continue to shape Earth's future. The end of the current continents is not the end of Earth's story. Rather, it is the beginning of a new chapter, one that will unfold over millions of years, bringing with it new opportunities for evolution, adaptation, and survival. In this new world, life will continue to evolve in response to the changing environment. The rise of new continents, the closing of oceans, and the shifting of climates will create new challenges and opportunities for species to adapt. And as life finds new ways to thrive in the changing world of Pangea Proxima, the end of the current continents will be seen as just another step in the ongoing process of Earth's transformation, a process that will continue for billions of years, shaping the planet and its ecosystems in ways we can only begin to imagine. As the formation of Pangea Proxima unfolds, and the Earth's surface is restructured by tectonic forces, we are left with a compelling contrast between the ancient landscapes that once existed and the modern reflections of those landscapes. Earth's geological history is written in layers, etched into the fabric of the planet through the slow but relentless movement of tectonic plates. The landscapes that shaped life on Earth in the distant past are not lost. Rather, they persist in the remnants of mountains, seas, and land masses that continue to influence the planet even as new ones take shape. As we observe the dramatic changes brought about by the collision of continents and the birth of a new supercontinent, we are forced to reflect on the ancient forces that once shaped Earth's geography and how those forces continue to echo through the landscapes of today and into the future of Pangea Proxima. The formation of Pangea Proxima will be an expression of the same geological processes that led to the creation of the supercontinent Pangaea hundreds of millions of years ago. The Earth's tectonic activity, which caused Pangaea to break apart, will eventually reassemble the continents into a new configuration. This ongoing cycle of continental collision and separation, known as supercontinent cycles, has shaped the Earth throughout its history, and Pangea Proxima will be the next iteration of this pattern. While the new supercontinent will bring with it dramatic changes, it will also reflect the ancient landmasses that preceded it. The most direct link between the ancient landscapes and the new world of Pangea Proxima will be found in the geological formations that persist even as the continents collide and reshape the Earth. Mountain ranges such as the Himalayas, the Andes, and the Alps were created through the collision of tectonic plates and will serve as reminders of Earth's ancient geological history. As the continents converge to form the supercontinent, older mountain ranges will be uplifted even further and new ranges will rise in their place. These ancient mountains, forged by the same tectonic forces, will stand as symbols of the relentless power of plate tectonics. For example, the collision between the Indian and Eurasian plates formed the Himalayas, the highest mountain range in the world. The Himalayas have been rising for millions of years, and this process will continue as Pangea Proxima takes shape. The collision of Africa with the Americas will give rise to an entirely new mountain range, but it will be shaped by the same tectonic principles that created the world's current landforms. Similarly, the Appalachian Mountains, which are remnants of an ancient mountain range from a previous supercontinent, will be restructured as new plates push against them, continuing to shape Earth's geography for millions of years. The coastal regions of Pangea Proxima will also reveal traces of the ancient oceans that once separated the continents. The closure of the Atlantic and Pacific Oceans, as the land masses come together, will erase these bodies of water from the map. Yet, the remnants of these oceans will persist in the form of ancient shorelines and underwater features. The Mid-Atlantic Ridge, for example, which marks the boundary between the Eurasian and North American plates, is a remnant of the spreading Atlantic Ocean. As the Atlantic closes, the ridge will become part of the newly formed supercontinent, serving as a reminder of Earth's ancient oceanic past. Similarly, the Pacific Ocean, once a vast body of water separating the Americas from Asia, will shrink, leaving behind a new geography marked by underwater trenches, volcanic arcs, and oceanic ridges that were once the defining features of the ocean. In addition to these physical remnants, the geological processes that shape the ancient continents will leave their mark on the future ecosystems of Pangea Proxima. As the continents collide, they will not only form new mountains and oceans, but also cause the rearrangement of biomes and ecosystems. Just as the breakup of Pangaea led to the isolation and evolution of species on different continents, the formation of Pangaea Proxima will create new opportunities for evolution, but also new challenges for survival. Species that once shared similar habitats will be forced to adapt to the new geography, or they will be separated by new barriers of mountains, deserts, and glaciers. In some cases, life will reflect the ancient landscapes of the past, evolving in ways that mirror the creatures that once roamed the Earth millions of years ago. For instance, the ancient supercontinent Pangaea was home to some of the most iconic creatures in Earth's history, such as the dinosaurs. As Pangaea Proxima forms, it will provide a blank slate for the evolution of new life forms that will adapt to the shifting climate and geography. These new species will be shaped by the same environmental pressures that drove the evolution of ancient species. In a sense, the modern reflection of the ancient world will come full circle, with new life forms emerging to fill the niches left by extinct species. Just as the breakup of Pangaea allowed for the diversification of life, the formation of Pangea Proxima will lead to the rise of new ecosystems and the adaptation of species to the changing environment. The climate of Pangea Proxima will also be influenced by the ancient patterns of the Earth's atmosphere and oceans. As the continents come together, the distribution of land and water will create new climate zones, much like those that existed when Pangaea first split. The supercontinent will likely experience extreme temperature fluctuations, with vast deserts in the centre and temperate climates along the coasts. The shifting climate will mirror the environmental conditions that existed on Earth during the early days of life, when the first land-dwelling creatures evolved in response to the challenges of the changing world. While Pangea Proxima will represent a new chapter in the Earth's geological history, it will also be a reflection of the ancient landscapes that once existed. The new supercontinent will bear the marks of its predecessors, with ancient mountain ranges, oceanic features, and ecosystems that have been shaped by the same geological forces. These ancient landscapes will serve as a reminder of the cyclical nature of Earth's history, where continents form, break apart, and reassemble over time. The rise of Pangea Proxima will be a reflection of this ongoing process, and as life adapts to the changing world, it will continue to be shaped by the ancient forces that have always driven the evolution of the planet. The story of Earth's continents is one of constant change and transformation, where the ancient landscapes of the past are reshaped by the tectonic forces of the present. The formation of Pangea Proxima will be a testament to the power of these forces, as the landmasses collide and merge into a new supercontinent. In this new world, the ancient landscapes of Pangaea will live on in the mountains, oceans, and ecosystems that persist in the future. These landscapes, though altered by the forces of plate tectonics, will continue to reflect the dynamic and ever-changing nature of the Earth, serving as a reminder of the long history that has shaped the planet we live on today and will continue to shape the world of tomorrow. As we imagine the future of Earth in the wake of the formation of Pangea Proxima, we are faced with the stark reality that the current human civilization will not exist in its present form. The collision of continents, the creation of new land masses, and the dramatic shifts in climate will reshape the planet in ways that will challenge humanity's adaptability. The role of human civilization in this changing Earth will be shaped not just by the physical transformation of the planet, but by how we respond to these changes. What will humanity's place be in a world where the familiar landscapes are erased and new ecosystems emerge? How will our societies adapt to the shifting geography rising mountain ranges, shrinking oceans, and changing climates that come with the birth of Pangea Proxima. At the heart of this challenge will be the fundamental question of human survival. Human civilization has for millennia adapted to the world's changing environments. From the Ice Age to the rise of agriculture, we have demonstrated a remarkable ability to adjust to new circumstances. But the world of Pangea Proxima will present an entirely new set of challenges, ones that may require unprecedented levels of adaptation. The climate, geography, and ecosystems of the future supercontinent will likely be drastically different from what we experience today. Vast deserts will emerge in the interior, while new glaciers will form at the poles, cutting off entire regions from the temperate zones we are familiar with. The reconfiguration of the oceans and the reshaping of coastlines will drastically alter the global supply of water and resources. The first and perhaps most immediate challenge humanity will face will be the movement of populations. As the continents converge and the oceans close, the land masses of Earth will be restructured, creating new coastlines and new inland regions. Coastal cities and civilizations that rely on access to the sea will have to adapt as the oceans shrink and new land bridges emerge. In some cases, regions that were once close to the coast will become isolated from the ocean, requiring people to develop new methods for accessing fresh water, trade routes, and food sources. In other areas, new coastlines will open up, creating opportunities for human settlement, but these new regions will come with their own challenges, shifting climates, new ecosystems, and perhaps unfamiliar dangers. The movement of tectonic plates will force humanity to reconsider how we interact with the environment and how we organize our societies. This geographical shift will also have profound implications for human agriculture and food production. The deserts of Pangea Proxima will be vast, with arid land stretching across the center of the supercontinent. Much like the desertification we see in certain parts of the world today, these new desert regions will require innovative agricultural techniques to sustain human populations. Technologies such as irrigation, climate-controlled agriculture, and genetically modified crops will become even more essential to feeding the growing population of Pangea Proxima. At the same time, the rise of new mountain ranges will disrupt weather patterns and precipitation cycles, creating more localized rainforests and wetland areas in some regions, while others may face droughts and extreme heat. Humanity will need to develop new methods for managing water, conserving soil, and ensuring a stable food supply in a changing world. The shifting climate will also influence human migration. As temperature patterns change and certain regions become inhospitable, populations will be forced to move, either in search of more hospitable environments or in response to resource scarcity. Large portions of Pangea Proxima may be dominated by extreme temperatures, with the central deserts becoming increasingly inhospitable as the supercontinent heats up. Regions closer to the poles may experience colder temperatures, with glaciers advancing over vast stretches of land. Coastal areas, on the other hand, could be more temperate, but subject to the rising of new oceans or the shrinking of others. The vast migration of people in search of more favourable climates will be an inevitable consequence of these shifts, leading to a reorganization of human society across the supercontinent. Ancient patterns of migration, where people moved in search of food and shelter, will once again become a central theme of human history in Pangea Proxima. In the face of these challenges, humanity's ability to innovate and adapt will be key. Our capacity to harness technology, develop sustainable agriculture, and build resilient infrastructure will determine how well we can survive and thrive in this new world. The technology of the future will need to focus not only on adaptation, but on mitigating the effects of climate change and minimizing the environmental impact of human activities. The rise of new, resource-rich regions, as well as the potential for resource scarcity in others, will require careful management of natural resources. The development of renewable energy, advanced water purification systems, and climate-resistant crops will be essential to ensuring that future civilizations can survive in the face of ever-changing climates. One of the key factors in humanity's success will be our ability to harness and manage the resources that the Earth's restructured geography provides. As the supercontinent forms, new mineral deposits will become accessible, and the land will provide new opportunities for agriculture, mining, and industry. The rise of new mountain ranges and the convergence of continents will create new natural resources that will drive human industry. However, these new resources will also require careful management to prevent environmental degradation. The ecosystems of Pangea Proxima will be different from those of today, and humanity will need to learn how to interact with these new environments in ways that promote sustainability. The future of humanity in Pangaea Proxima will depend on our ability to balance the demands of civilization with the health of the planet. While the formation of Pangaea Proxima will present monumental challenges, it will also offer humanity the opportunity to develop new ways of thinking about our relationship with the Earth. The vast new landscapes that emerge will provide opportunities for innovation and growth. As humans adapt to the changing geography, they will learn to live in harmony with the dynamic forces of nature, just as they have done throughout history. However, the fate of human civilization will also depend on our ability to cooperate and build new social, political, and economic systems that support sustainability, equity, and resilience in a world that is in constant flux. The role of human civilization in a changing Earth will be both a test of our adaptability and a testament to our ingenuity. The challenges that we face in Pangaea Proxima will require us to think critically about how we live on this planet, how we share resources, and how we ensure that future generations can thrive in a world of constantly shifting geography and climate. It will be a time for humanity to reflect on our place in the natural world and take steps toward a future where we work with, rather than against, the forces of nature. The formation of Pangaea Proxima will be the beginning of a new chapter for human civilization, one that will be shaped by the geography, climate, and ecosystems of a planet that is ever-changing, ever-evolving, and full of new possibilities. In the end, the role of human civilization in Pangaea Proxima will be defined by our ability to rise to the occasion, to adapt to the changing world around us, and to forge a path toward a sustainable, resilient future on this dynamic planet. As the landscape of Earth is radically transformed by the formation of Pangaea Proxima, the future of cities and human habitats will be shaped by the shifting geography, changing climates, and evolving ecosystems of the supercontinent. The reconfiguration of the continents, the closing of oceans, the rise of mountain ranges, and the emergence of new desert and glacial regions will create new challenges and opportunities for human habitation. The cities of the future will need to adapt to the extreme conditions of this new world, as humanity's reliance on natural resources, water, and fertile land will become more critical than ever before. One of the first challenges humanity will face in Pangaea Proxima is the availability of water. The closing of the Atlantic and Pacific Oceans and the formation of inland seas will change the distribution of freshwater sources. In the central regions of the supercontinent, vast deserts will emerge, leaving large areas without sufficient access to water. At the same time, new rivers, lakes, and seas will form in other areas, creating opportunities for human settlement in previously uninhabitable regions. The future of cities will depend on their ability to secure access to water in this new geography. Urban areas may need to rely on advanced technologies such as desalination, water recycling, and efficient irrigation systems to meet the demands of a growing population. Water management will become one of the most critical factors in the development of sustainable cities, with the ability to conserve, store, and transport water becoming paramount. The rise of new mountain ranges and the disruption of existing coastlines will also have significant implications for human habitation. Coastal cities, which have long been the centres of trade and commerce, will no longer be located along the same coastlines as they are today. As new coastlines form along the edges of the supercontinent, human settlements will shift to these newly exposed regions. These new coastal cities will face different challenges, including the risk of flooding, more extreme weather patterns, and the need for resilient infrastructure. Rising sea levels caused by melting glaciers and shifting ocean currents will make some coastal regions more vulnerable, while others may benefit from the creation of new harbours and trade routes. The rise of coastal cities in Pangea Proxima will depend on the stability of the land, the accessibility of resources, and the ability to adapt to the new climate. The shifting geography of Pangea Proxima will also affect the distribution of arable land. The vast deserts that emerge in the centre of the supercontinent will require new forms of agriculture. The cities that develop in these regions will need to rely on innovative farming techniques, such as vertical farming, hydroponics, and controlled environment agriculture, to produce food in the arid conditions. Technologies that allow for the efficient use of water, soil, and energy will be critical to sustaining life in these harsh environments. The future of cities in these regions will be marked by a focus on sustainability, with an emphasis on resource-efficient technologies that allow urban populations to thrive despite the challenges posed by the environment. At the same time, the new mountain ranges and changes in climate will also create fertile regions along the coasts and in the temperate zones. These areas will become hubs of agricultural production, supporting large urban populations that rely on the land to produce food and other resources. Cities in these fertile regions will likely develop around access to key resources, including water, land for agriculture, and proximity to trade routes. The future of these cities will be shaped by their ability to manage resources sustainably and by their capacity to adapt to the changing climate. As new mountain ranges rise and the climate shifts, cities will need to adjust to new patterns of rainfall, temperature, and seasonal changes. The architecture and infrastructure of these cities will reflect the demands of the environment, with energy-efficient buildings, green spaces, and water conservation systems becoming essential features of urban design. The transformation of Pangea Proxima will also create new opportunities for human settlement in areas that were once inhospitable. The collision of continents will give rise to new land masses and areas that were previously cut off from one another. The formation of inland seas and large river basins will provide opportunities for the development of new cities in these once uninhabitable regions. These new settlements will be centred around natural resources such as fresh water, fertile land, and mineral deposits. Cities in these areas will need to develop strategies for protecting these resources from overuse and ensuring that they remain sustainable for future generations. New methods of urban planning, energy production, and waste management will be essential to supporting life in these newly emerging regions. The technological advancements that will define the cities of Pangea Proxima will be focused on adaptation and resilience. The future of urban development will rely on smart cities, highly efficient interconnected hubs that use data and technology to optimize resources, manage infrastructure, and mitigate environmental risks. The use of renewable energy sources such as solar, wind, and geothermal will be critical to reducing humanity's dependence on fossil fuels and minimizing the environmental impact of urbanization. Advanced transportation systems will ensure that people and goods can move efficiently across the supercontinent, even as geography changes and new barriers emerge. High-speed rail, electric vehicles, and automated delivery systems will become the backbone of human mobility in Pangea Proxima. In addition to these technological innovations, the rise of new cities will also require a rethinking of social and political structures. As humanity adapts to the changing Earth, cities will need to develop new forms of governance that prioritize sustainability, resilience, and cooperation. Global cooperation will become even more crucial as the challenges of managing resources, protecting ecosystems, and ensuring equitable development become more pressing. In Pangea Proxima, cities will not exist in isolation. They will be part of a larger interconnected network, relying on one another for trade, resources, and knowledge exchange. The cities of the future will need to foster collaboration and innovation, not only to survive but to thrive in a rapidly changing world. The rise of cities in Pangea Proxima will also mark a new chapter in human history. These new cities will reflect the enduring adaptability of humanity in the face of environmental and geological changes. The cities of the supercontinent will be built with a deep respect for the natural world, incorporating sustainable technologies and designs that allow humanity to live in harmony with the shifting landscapes. Whether in the temperate coastal regions, the arid deserts, or the fertile plains, the cities of Pangea Proxima will be a testament to human ingenuity, resilience, and our ability to create sustainable habitats in the face of unprecedented challenges. The future of human habitats in Pangea Proxima will be a complex and dynamic story, one that unfolds over millions of years, shaped by the forces of nature and the innovative spirit of humanity. The rise of new cities, the adaptation of human societies to the changing geography and climate, and the ongoing evolution of technology will define the future of human civilization on this ever-changing supercontinent. While the Earth will undergo dramatic transformations, the resilience and adaptability of humanity will ensure that we continue to find new ways to live, work, and thrive in the world of tomorrow. As the tectonic plates of Earth slowly converge to create Pangea Proxima, the formation of a new supercontinent will not only mark a monumental shift in geography and climate, but will also give rise to an entirely new chapter in human history, the Age of Exploration. Just as earlier explorers in Earth's history sought to chart unknown lands and new continents during the Age of Discovery, future generations will embark on a quest to explore a world reshaped by the collision of land masses. The new geography of Pangea Proxima, with its vast inland seas, newly formed mountain ranges and shifting coastlines, will provide a fresh frontier for human curiosity, innovation, and adventure. The Age of Exploration in Pangea Proxima will be driven by humanity's desire to understand, map, and ultimately harness the vast resources of the new supercontinent. As Earth's continents are reunited into a single landmass, the very nature of exploration will change. No longer will vast oceans separate humanity from distant continents, but instead, newly emerging geographical features, such as expansive deserts, deep valleys, towering mountain ranges, and large inland seas, will create a new set of challenges for explorers. The coastline will be dramatically different from the one we know today, with entire regions once bordered by oceans now forming new coastlines, creating an entirely new map of the world to be explored. The rise of Pangea Proxima will bring humanity's age-old desire for discovery to the forefront. The new supercontinent will span a vast range of landscapes, climates, and ecosystems, from the arid deserts in the centre to the lush coastal rainforests and towering alpine ranges at the peripheries. Just as early explorers set sail to uncover new lands, future explorers will seek to traverse the vast expanse of Pangea Proxima, uncovering its mysteries and mapping its complex geography. The inland seas will be a particularly intriguing feature, offering opportunities for new maritime exploration. These seas, isolated from the wider oceans, will hold a unique place in the history of Pangea Proxima's exploration. They will act as hidden waterways, connecting distant regions of the supercontinent that were previously inaccessible and providing new routes for trade, travel, and cultural exchange. The rugged terrain of the supercontinent will test the ingenuity and resilience of future explorers. The collision of continents will create towering mountain ranges that stretch across vast distances. These ranges will become the natural barriers of the supercontinent, marking regions of isolation and serving as both obstacles and opportunities for those daring enough to cross them. The rise of new mountain chains will not only be a challenge to explorers, but will also be the setting for some of the most exciting achievements in human history. The desire to scale these formidable peaks, cross vast deserts, and navigate uncharted inland seas will drive explorers to develop new methods of transportation, engineering, and survival techniques. Much like the great explorers of the past, future adventurers will rely on new technologies to overcome the physical challenges presented by the landscape. The cities of Pangea Proxima will be interconnected by advanced infrastructure, allowing explorers to traverse the supercontinent with relative ease. High-speed rail networks, automated transportation systems, and perhaps even airborne or subterranean modes of travel will allow explorers to navigate vast distances quickly and efficiently. These advances in technology will be essential for opening up the farthest reaches of Pangea Proxima to exploration, enabling humanity to uncover the secrets of the new supercontinent and harness its natural resources. The new geography of Pangea Proxima will also foster the creation of new trade routes and economic systems. Just as the great explorers of the past paved the way for global trade and cultural exchange, the adventurers of the Age of Exploration in Pangea Proxima will facilitate the flow of goods, knowledge, and ideas across the supercontinent. The inland seas will provide vital access to trade hubs, while the new mountain ranges will offer opportunities for resource extraction and mining. The desire to access these resources, as well as to understand the land's biodiversity and climates, will fuel the exploration of previously remote regions. In addition to material resources, the exploration of Pangea Proxima will lead to the discovery of unique ecosystems, new species of plants and animals, and untapped potential for scientific study. As humanity spreads across the supercontinent, scientists and naturalists will be driven to catalogue the life forms that thrive in the new world. The deserts, once hostile and barren, will reveal secrets about survival in extreme environments, with species evolving to withstand the harsh heat and scarcity of water. The lush rainforests along the coasts and the fertile plains of temperate zones will hold an abundance of undiscovered flora and fauna, with the potential for new medicines, foods, and natural resources to be discovered. The process of exploration will fuel humanity's understanding of the natural world, leading to new breakthroughs in medicine, ecology, and environmental science. However, as with any era of exploration, the search for new lands will come with its own set of challenges and ethical dilemmas. The clash between civilizations, the displacement of indigenous species, and the exploitation of resources will pose significant questions for the explorers of Pangea Proxima. How will humanity balance the desire to explore and expand with the need to preserve the natural world and respect the ecosystems that are already in place? What responsibility will future explorers have to ensure that their discoveries and actions do not lead to the destruction of fragile environments or the extinction of species? These are questions that will need to be addressed as humanity embarks on its journey through the new supercontinent. The exploration of Pangea Proxima will not just be a physical journey, it will be an intellectual and cultural one as well. As explorers chart the land, they will discover not only new territories, but also new ways of thinking about the world. The shifting geography and climate of the supercontinent will challenge old paradigms and inspire new ways of understanding how humanity fits into the natural world. The interconnectedness of regions across the supercontinent will foster new cultural exchanges, allowing for a blending of ideas, art, and knowledge from previously isolated regions. The explorers of Pangea Proxima will be pioneers not just in geography, but in philosophy, technology, and society, helping to build a future world that is more interconnected and more attuned to the natural rhythms of the planet. The age of exploration in Pangea Proxima will ultimately be a celebration of human curiosity, resilience, and the drive to understand the world. Just as the explorers of the past helped shape the modern world by expanding our knowledge and pushing the boundaries of human potential, the explorers of the future will shape the new supercontinent by charting its landscapes, unlocking its resources, and discovering new ways of living in harmony with the planet. This new era of exploration will mark the beginning of a new chapter in the story of humanity, a chapter where the forces of nature, technological innovation, and the human spirit combine to create a world that is as dynamic and ever-changing as the Earth itself. In the end, the age of exploration in Pangea Proxima will not only shape the future of the supercontinent, but also remind humanity of its place in the ever-evolving story of the Earth. As explorers set forth to uncover the mysteries of the New World, they will continue to push the boundaries of discovery, ensuring that the spirit of exploration remains a driving force in human history for generations to come. As we look toward the formation of Pangaea Proxima and the incredible changes it will bring to Earth's geography, it's essential to consider the timescale on which these transformations are occurring. The geological processes that drive the collision of continents, the formation of new mountains, the closing of oceans and the rise of supercontinents unfold over periods of time that stretch far beyond a human lifetime or even the span of recorded history. To truly understand the creation of Pangaea Proxima and the forces that shape it, we must examine Earth's geological calendar, a timeline that spans billions of years, marking the slow but relentless pace at which our planet's surface changes. Geologists divide Earth's history into eons, eras, periods and epochs, with each unit of time representing a significant shift in the planet's geological or biological history. The formation of Pangaea Proxima is a natural part of this ongoing cycle, a continuation of the supercontinent cycles that have defined the Earth's history for nearly 2 billion years. These cycles, driven by the movement of tectonic plates and the forces of mantle convection, cause the continents to periodically come together and break apart, reshaping the planet's geography and influencing the evolution of life. To understand where Pangaea Proxima fits into the geological calendar, we need to consider the broader context of Earth's geological history. The Earth formed around 4.5 billion years ago, with its surface shaped by a series of catastrophic events, including volcanic activity, asteroid impacts, and the gradual cooling of the planet. The first known supercontinent, Rodinia, formed around 1.1 billion years ago and eventually broke apart, setting the stage for the formation of Pangaea. Pangaea itself formed around 335 million years ago, marking the beginning of a new chapter in Earth's history. It existed as a single landmass for over 100 million years before it began to break apart, leading to the continents we recognize today. The breakup of Pangaea, which began around 175 million years ago, set the stage for the current configuration of the continents. As the continents drifted apart, new ocean basins formed, and the land masses took on their current shapes. However, the forces that caused Pangaea to break apart also ensured that the Earth's surface would not remain static for long. Tectonic plates continue to move, and over time, the continents will once again collide and fuse to form a new supercontinent, Pangaea Proxima. The geological timescale on which these events occur is vast, with tectonic processes unfolding over tens of millions to hundreds of millions of years. The movement of tectonic plates is so slow that it's nearly imperceptible within a human lifetime, but over the course of millions of years, the cumulative effect of this movement is immense. For example, the plates that form the Atlantic Ocean are moving apart at a rate of around 2.5 centimeters per year. This may seem slow, but over millions of years, it adds up to significant shifts in the planet's geography. Similarly, the subduction of oceanic plates beneath continental plates is a slow but powerful process that results in the formation of mountain ranges, volcanic arcs, and oceanic trenches. To understand the geological calendar of Pangaea Proxima, we need to consider the cycle of supercontinents. Earth's history has been marked by the formation and breakup of supercontinents, each one shaping the planet's geology and climate in unique ways. The formation of Rodinia, Pangaea, and Pangaea Proxima represents a recurring pattern in Earth's history, driven by the forces of mantle convection and the movement of tectonic plates. The process of continental drift that will eventually create Pangaea Proxima has already begun, with the continents slowly converging toward one another. This process will take millions of years to reach its culmination, but when it does, Earth will once again be dominated by a single landmass, just as it was during the age of Pangaea. The geological calendar also reminds us that the formation of Pangaea Proxima will be a gradual and ongoing process. While it may seem like a sudden event, the reality is that it will unfold over tens of millions of years, with the continents slowly converging and the oceans closing, in response to the tectonic forces at work beneath the Earth's surface. Over this long time scale, many changes will take place, not just in the land masses themselves, but in the climate, ecosystems, and distribution of life on the planet. As the continents come together, they will reshape ocean currents, alter atmospheric circulation, and create new regions of aridity and moisture. The new supercontinent will create an entirely different world, but it will do so gradually, with each geological event contributing to the overall transformation of the planet. When we look at the geological calendar, it's clear that the formation of Pangea Proxima is just one chapter in a much larger story. The Earth's surface is constantly in flux, shaped by the slow-moving forces of plate tectonics and the dynamic nature of the planet's interior. Over the course of billions of years, the Earth's geography has been reshaped again and again, with supercontinents rising and falling in an ongoing cycle. The creation of Pangea Proxima will be another step in this cycle, and it will be followed by the eventual breakup of the supercontinent, leading to the formation of new land masses and the continuing evolution of life on Earth. For humanity, the geological calendar offers both a humbling perspective and an exciting opportunity. While we may not live to see the formation of Pangea Proxima, the process that will shape this new supercontinent is ongoing right now. The movement of tectonic plates, the shifting of ocean currents, and the forces of volcanic activity are all part of the world we live in today, shaping the future in ways we cannot fully comprehend. The geological calendar reminds us that Earth's history is far older than our own civilization, and that the forces at work beneath our feet will continue to shape the planet long after humanity has come and gone. This perspective allows us to appreciate the scale of Earth's transformation, and to understand that the planet's history is not a linear progression, but a series of cycles, each one leading to new beginnings and new challenges. As we consider the future of Earth and the formation of Pangea Proxima, we must remember that we are part of this ongoing story. Our brief moment in Earth's geological history is just a blip on the timescale of the planet, and while we may not live to see the creation of a new supercontinent, our actions today will influence how humanity adapts to the changing world in the coming millennia. The forces that drive the creation of Pangea Proxima will continue to shape the Earth, but it is up to us to ensure that we respond to these changes in ways that protect the planet and promote sustainability. In doing so, we can play a small but important role in the larger ongoing story of Earth's geological evolution. The geological calendar, stretching over billions of years, will continue to turn, and humanity will be a part of that story as it unfolds. Imagine stepping into a machine, one that transcends the limits of time and space, and travelling forward to the distant future of Earth. You're not a mere observer, you are a traveller, witnessing firsthand the slow but inevitable changes that have shaped the planet. You step out of the time machine and look around. Vast, sweeping deserts stretch for miles in every direction, interrupted only by towering mountain ranges that rise from the land like colossal stone sentinels. In the distance, the edges of massive inland seas shimmer beneath the sun, their water seemingly endless and yet disconnected from the oceanic world you once knew. This is not the Earth you know today. This is the world of Pangaea Proxima, a new supercontinent born from the relentless movement of tectonic plates, a world shaped by forces far beyond human comprehension, a world unlike anything you've ever imagined. As you walk across this transformed landscape, you realize that the very geography of Earth has changed. The familiar continents that once stretched across the globe are gone, replaced by a vast landmass that connects almost all the major continents. You look up at the sky, where the weather is unfamiliar, the patterns of clouds and wind utterly different from what you once knew. In this world, the central regions of the supercontinent are scorched by the relentless heat of the sun, their deserts stretching from one end of the land to the other. The inland seas, isolated from the world's oceans, shimmer in the heat, offering pockets of life amid the harshness of the dry land. The coastlines are not what you expected either. They're marked by new shores, reshaped by the slow but powerful forces of tectonic activity. Where oceans once separated the land masses, now only narrow seas and river zones remain, their waters bearing the marks of millions of years of geological upheaval. Looking around at the scene before you, it's clear that this is a world in transition. The Earth is no longer a patchwork of continents separated by vast oceans, but a singular landmass, a supercontinent bound together by geological forces. The creation of Pangea Proxima is a culmination of billions of years of tectonic activity, a moment in Earth's history that has reshaped the planet's surface and set the stage for an entirely new era. The continents, which once drifted apart over millions of years, have now converged, and their collision has given birth to a world that is both familiar and alien. The new supercontinent is a product of nature's slow, relentless power. And as a time traveller, you are witnessing a world where Earth's landscape has been radically reshaped by the same tectonic forces that have driven the evolution of life itself. As you venture further into this world, you encounter a city nestled in the coastal region of Pangea Proxima. It is a city unlike any you have ever seen, shaped by the unique geography and climate of the supercontinent. Towering, energy-efficient skyscrapers rise up from the ground, designed to withstand the intense heat and harsh winds that are common in this new world. Solar panels cover every building, and wind turbines stand tall, harnessing the energy of the ever-blowing winds that sweep across the coast. The city is built with sustainability in mind, a response to the changing environment that humanity now calls home. There are no traditional vehicles on the streets. Instead, you see automated electric cars and high-speed rail systems which connect the city to distant parts of the supercontinent. The city is a beacon of human ingenuity, a testament to the adaptability of civilization in the face of an ever-changing world. As you walk through the bustling streets, you notice that people are living in harmony with their environment. The architecture is designed to minimize resource consumption, with green spaces interwoven throughout the city and water management systems that make the most of the limited resources available. These advancements are the result of centuries of adaptation, technological innovation, and a deep understanding of the planet's evolving needs. The cities of Pangaea Proxima, shaped by the forces of plate tectonics, are proof that humanity can thrive even in the most extreme of environments. But it is not just the cities that are remarkable. The natural world in Pangea Proxima has also adapted to the dramatic shifts in geography. The once lush forests, the vibrant oceans, and the fertile plains have given way to new ecosystems that are shaped by the harsh deserts and towering mountain ranges that dominate the supercontinent. The animals and plants that inhabit this world have evolved in response to the changing conditions, adapting to the extreme temperatures, shifting climates, and altered landscapes. New species of plants and animals have emerged, some adapted to the arid conditions of the central deserts, while others have evolved to survive in the lush coastal rainforests that cling to the edges of the supercontinent. You witness these new life forms thriving in the transformed environments of Pangea Proxima. In the vast deserts, you see creatures that have evolved to conserve water, using specialized adaptations to survive in the dry, scorching heat. These animals are unlike any you've seen before, with thick, leathery skin that shields them from the intense sun, and specialized organs that allow them to retain moisture for extended periods. In the coastal rainforests, you encounter a rich tapestry of life, plants with unique mechanisms for absorbing water and animals that have evolved to thrive in the temperate, humid environment. The biodiversity of Pangea Proxima is staggering, shaped by millions of years of evolutionary pressures and the ever-changing geography of the supercontinent. As you continue to explore, you come to realize that the forces of nature, both geological and biological, are inextricably linked in this new world. The rise of new mountain ranges, the closing of oceans, and the shifting of climates have given rise to entirely new ecosystems that are as dynamic as the forces that created them. The world of Pangea Proxima is not static. It is a living, breathing entity, constantly evolving in response to the forces that shape its surface. In your reflections on this future world, you begin to understand the true scope of Earth's geological timeline. The creation of Pangea Proxima is a moment in a much larger cycle, a cycle of constant change and transformation that has shaped the planet for billions of years. The Earth, in its slow but relentless journey through time, has undergone countless transformations, and each new supercontinent is a testament to the power of tectonic activity and the dynamic nature of the planet. As a time traveller, you realise that the world you are witnessing is not the final destination of Earth's journey, but a fleeting chapter in a story that will continue long after humanity is gone. As you step back into the time machine ready to return to the present, you take one last look at Pangea Proxima, this new supercontinent shaped by the same forces that have driven Earth's evolution for billions of years, stands as a monument to the power of change and the inevitability of transformation. The Earth is constantly evolving, its surface reshaped by the slow but unstoppable forces beneath. And as a time traveller, you have had the privilege of witnessing a moment in Earth's history that few will ever fully understand. A moment when the planet's geography, ecosystems and human civilization have been redefined in ways that will echo for millions of years to come. As we bring our journey through the future of Earth to a close, we're reminded that the forces shaping our planet are often quiet, unseen, and imperceptible to the human eye. Tectonic plates move with a slowness that seems almost imperceptible, and the continents drift at a pace that is too gradual for any of us to directly observe in our short lifetimes. Yet, over millions of years, these slow, relentless forces shape the geography of the Earth in ways that define the future of life on the planet. The formation of Pangea Proxima, the rise of new mountains, the closing of oceans, and the dramatic shifts in climate are all the result of these invisible, yet incredibly powerful forces of nature. It's easy to forget just how dynamic and ever-changing the Earth truly is. From the surface, it may seem like the land is fixed and unchanging, but beneath the ground, the forces of plate tectonics are constantly at work, shaping the continents, driving the movement of the oceans, and causing the Earth's crust to constantly shift and evolve. These processes are so slow that we cannot perceive them in real time, but they are the foundation of the planet's evolution, and the changes they bring about will echo through the future, from the rise of supercontinents like Pangea Proxima to the eventual breaking apart of those same landmasses. As we think about the quiet, unseen forces of nature, it's also important to consider their deep connection to life on Earth. The climates we experience, the ecosystems that thrive across the continents, and the very land we inhabit are all shaped by these slow-moving forces. When we observe a mountain range or a deep ocean trench, we are witnessing the culmination of millions of years of geological activity, of subtle movements beneath our feet that have shaped the world we live in. These forces also influence the evolution of life. Species adapt to changing climates, shifting continents, and new geological features. Over time, life responds to these quiet changes, evolving to thrive in new environments and new landscapes, just as it will in the world of Pangea Proxima. The Earth's transformation is not something that we can experience in the immediate sense. In our human lifetimes, the changes seem too slow, too distant to notice. But when we step back and view the history of the planet as a whole, we can see how the forces of nature have shaped the Earth into a dynamic, ever-evolving system. These quiet, unseen forces work together to shape the world around us, carving out new landscapes, creating new ecosystems, and offering new opportunities for life to adapt and thrive. As we consider the future of Pangea Proxima and the Earth's geological history, it is a reminder that the world we live in is constantly changing, both in ways we can see and in ways that remain hidden beneath the surface. The forces of nature, though often imperceptible, are the true architects of Earth's past, present, and future. They remind us that the Earth is not a static, unchanging entity, but a dynamic, living planet that is constantly evolving. Just as the landmasses have drifted and collided over millions of years, so too will the Earth continue to transform, shaping a world that is always in motion, always changing, and always evolving. In the grand sweep of geological time, our lives are but a brief moment, but we're still part of the Earth's ongoing story. The quiet forces beneath our feet remind us of the planet's long history, the vastness of time, and the inevitable cycles of change that will continue long after we're gone. And in that quiet, unseen process, we can find both humility and awe as we reflect on the way nature works its quiet magic, transforming the world in ways we can hardly comprehend. As the Earth moves forward towards the birth of Pangea Proxima and beyond, the forces of nature will continue to shape the world, quietly and powerfully, and, as observers of this ever-changing world, we can only look on in awe at the majesty of the planet and the unseen forces that drive its transformation, knowing that we are but a small part of a much larger, ongoing story. The Earth will continue to evolve, and we will continue to adapt, just as we have for millennia, silent witnesses to the profound power of the forces that shape our world